Hey guys, I welcome you all to the live session on AWS DevOps full course by Intellipaat. Today we have our colleague who is also a cloud enthusiast and who has helped us in curating this video of the day. Let's meet him and ask few questions about AWS DevOps. Hi Cody, I welcome you to the session.
Thank you.
So tell me Cody, why one has to learn AWS DevOps and why specifically AWS for DevOps?
So the first question is obviously why AWS DevOps, which is obviously a frequently asked question. There are so many other DevOps tools, and why to choose AWS DevOps is because AWS is a highly reputed firm for what they do and what cloud services they provide. And basically AWS DevOps is a set of developer tools which provides us every single tool in order to automate the entire software development lifecycle. And the second question was why AWS specifically for DevOps? It is because AWS is again the largest cloud provider in the world. The number of services they provide and the reliability using those services are much better than the other cloud providers. And to use AWS DevOps and combined with AWS, that basically gives us better reliability and a better performance in our company. And also why AWS for DevOps, there is another type of an answer which basically talks about the career opportunities, as again AWS is the biggest cloud provider and thus the career opportunities are in abundance and also with a great pay.
So guys, let's see the next question. So Cody, tell me, how can an individual or a company get benefited by learning AWS and DevOps?
Okay, so looking at the individuals, you don't need any guidance to start off with AWS DevOps because all you need is an AWS account. You don't need to pay anything to start off with AWS DevOps.
Yeah.
And as I told you, it is a set of developer tools which combines all of the tools which need to put together a complete software development lifecycle. And when coming to a company, any company wants to automate any task they want. For example, if there is front-end, back-end, whatever it is, a company wants to automate every single task they have. For example, if a developer codes, then uploads it, and then a tester downloads it, and the tester basically tests and puts the code back again by pushing it, and then again another person reviewing it. So this will take a lot of time. So now when it comes to DevOps, the only process where people are involved is the starting, planning, and the coding part, and then basically everything is set up and everything is automated. That basically can reduce the time a company works on a particular project and can give the product to the customer even faster than before.
So guys, let's see the next question. Cody, we all have heard about popular DevOps tools like Jenkins and GitHub. What are the alternatives of these tools in AWS DevOps?
Okay, so if we look at GitHub, it's a version control tool. So like that, in AWS DevOps, there is a tool called CodeCommit, which is especially for this purpose. CodeCommit is a version control tool which you can start off with. And comparing to Jenkins, so Jenkins is a CI/CD tool which we can use to automate or build and release cycles. So in AWS DevOps, we have a tool called CodePipeLine, and also there is a tool called CodeDeploy, which we can combine and use for both building the tool, deploying the tool, and finally releasing it to a server. So these two are the alternatives to GitHub and Jenkins. So to cover other tools, there are other tools as well. For example, there is CodeBuild, especially for building, and there is artifacts to store the created artifacts, and also, as I told you, CodeCommit, CodeDeploy, and CodePipeline.
So guys, before we begin the session, make sure to hit the subscribe button.
And also hit the notification icon so that you don't miss our upcoming updates, as well as leave a like if you enjoy our content.
On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to AWS. After that, we will introduce you to DevOps and its basic concepts. Then later on, we will learn about AWS DevOps integration.
So once we learn that, we'll move on to learn the services provided by AWS DevOps, which are CodeBuild, CodePipeline, CodeCommit, and CodeDeploy. Once we learn about that, we'll move on to learn an infrastructure as a code tool, which is called as Terraform. After we learn that, we'll move on to understand the career path of an AWS DevOps engineer.
Then after that, we have covered lots of hands-on demo and interview preparation. So, this is the agenda of the video. Without any further delay, let's get started.
So guys, cloud computing is nothing but the use of remote servers on the internet to do a particular task, right? Now you would ask, like, why do we need to connect to remote computers when I can do everything on my personal computer? Now imagine if you have an application which requires a lot of processing, right? So what will you do? Will you buy a server which has a lot of processing power, put your application over there, and then see how your application is functioning? Or if I give you one more option, that you can rent a server from a cloud provider and basically do a RDP or an SSH into that, put your application over there and see the working of that application, how it runs. And I'll also tell you that the moment you are done with the server, you can just give it back to me and I'll charge you only for the time that you used it. On top of that, what if I tell you that it's as cheap as $0.0005 per hour? Isn't that amazing? And that is exactly what cloud computing is all about, guys. So cloud computing, for a beginner, it's nothing but the use of remote servers for a personal needs, right? And rather than using our own computers or rather than buying servers of our own, I just want to rent a server on a cloud and I will pay them accordingly to the time that I have used, and the prices are as low as the figure that I just told you, right? So this is what cloud computing is, guys. Now you would wonder how it actually came into the picture, right? So let's go ahead and understand that. Alright guys, so let's take an example to understand this. Imagine you're a developer and you created your first app, which you think is going to be a hit, right? So how do you make this app available to the world, right? Or how do you make this app or website available to the world? So what do? You buy some servers and you put that application over there, right? And just putting your application on the servers would not do it. You'll have to connect it to the internet. And once you connect it to the internet, that is when people start to come on your application, come on your website and start to use it. All right. So this is how typically work used to be done. Now I want to take your focus onto certain things that I just said when I was explaining you this example. First of all, I will have to buy these servers. Right? And guys, servers are not cheap. They're very expensive, and buying a stack of servers will already cost you a lot of money. And you're not even sure whether your app will be a hit or not, right? You've just created your app and you want to try it out and you put it on some servers, and because you want to make it production grade, obviously you'll have to buy a stack of servers, which is going to cost you a lot, right? Second thing is, you will have to configure everything manually. If these servers have to be connected to the internet, you will have to do the connections, to this servers manually. You'll have to set up a static IP address. So you'll have to contact your ISP and say that, I need a static IP address for my servers so that people can just go to one particular address and they can visit it. After that, you again have to buy a domain. Let's say if you go to Intellipaat.com, you see the website, right? So what is happening? Intellipaat.com in the backend, the domain is getting converted into an IP address by a DNS server, and then that IP address is basically pointing to the servers, right? So you will have to buy a domain, you will have to point that domain to these servers, and that's how it used to work, right? And obviously, if you have these servers, you'll have to hire a team also who's gonna manage these servers in case the number of users increase. You'll have to increase the number of servers, etc., etc. There are a lot of things that you'll have to do. And because of these things, there were some problems. And because we wanted to overcome these problems, we use cloud computing. Right now, like I said, you were using this kind of an architecture before. Now let's see if we don't use this kind of an architecture and I just use cloud computing, what is going to be the difference? The difference will be that I created my application. Next thing is I'll go to AWS, I'll launch a stack of servers, I'll put my application over there. AWS automatically gives me a static IP address. It has a service to basically give me a domain name as well. I would just configure my domain name to connect to this IP address and I'm done, right? It's so much ease that I don't have to hire a team to manage my servers, because AWS says whatever servers you want to launch, I'm going to handle it for you. Not AWS, it's in fact any cloud provider for that matter. All the servers are managed by them. All the hardware upgradations are managed by them. Everything is managed by the cloud provider. And that is why cloud computing model itself is such a big hit, right? So what are the advantages? The first thing is that there is little or no investment. So I don't have to buy a stack of servers to get my application up and ready. I can just rent them, right? And the cost is minimal for launching the stack of servers and basically getting them up and ready, right? I don't have to invest much. Even though I'm starting fresh, I've just launched my application. I don't need seed money for setting up an infrastructure which is going to be huge for the whole world to see, right? The whole world can access your application, but you don't have to worry about it because AWS is backing you up, right? So there is little or no investment. Second thing is more focus on app development. So you can focus more on app development than worrying about whether my infrastructure is fine or not, how is the traffic coming onto my app, is my infrastructure scalable enough that it can handle all the traffic which is coming onto it. Everything is managed by AWS once you configure it correctly, right? Third thing is it requires less workforce. So like I said, if you are buying your own servers, you obviously have to have a team which is going to manage your servers for you, right? Any hardware upgradations, any security patch that you have to do, all of that is done by a team. Correct. But if you are launching your infrastructure or if you're creating your infrastructure on any cloud provider, the cloud provider's headache is to manage the servers. It's their headache to do the security patches. It's their headache to improve or the product. So all of that is managed by your cloud provider, and all you will do is focus on your app, focus on your business goals, and then succeed towards the goal that you have, right? So this is an advantage when you use cloud computing, and that is why most of the companies today, so I guess only the companies who started out earlier, that is before cloud computing, are working, hosting their own apps. But companies who have just started out, for example, prefer their servers to be on the start new company, you have very limited you can invest in things. Always a good idea to invest on the acquired, and rest, if it works in a server not costing you much, it works that way, right? So for startups especially, cloud computing is a huge thing. It's a huge bonus, and that is why you can see a lot of new business idea, own app or their own website service. Reason being, the major part of starting up a business was setting up the infrastructure that is handled by cloud computing these days, right? And that is why you can see more and more young companies are coming up and they are trying out an app. If they fail, there was little investment involved in it, so it doesn't matter. And that is what the entrepreneurs of guys, these are the advantages of cloud computing. Moving forward now, because cloud computing is so huge, there are a lot of products which are available. Even know we're not. For example, Netflix is the every life service. Their infrastructure is on AWS. Everything from A to Z, the scaling part, the content delivery network, the networking part, the security part, everything is handled by AWS. Now, don't worry, guys, if you don't understand the jargons that are just used, like content delivery network, secure, explain. I just want to tell you guys that because of the advantages that cloud computing has to offer, and because of the kind of that you get from cloud, companies such as Netflix, Airbnb, Amazon rely on infrastructure of the cloud providers so that they never go down to switch to cloud. So I'll give you a very small example. Netflix suffered a huge blackout on the internet around 2008, wherein all the services were down. More number of users came up to use the service, and that's when the service crashed, went down, and it caused a huge loss to the net, right? And that is when they decided, dude, I cannot manage all my servers, do the app. There's only one thing that I can do. So then Netflix started to migrate itself on the AWS infrastructure, which is highly scalable, which is highly available, right? And now seldom do you see that, in my experience, I've never seen Netflix down since I've been using it from the past 2-3 years. I've never seen Netflix down, or I've never seen an error that, the server is out, problem with the infrastructure. I've never seen that, right? And that is availability that is provided by the cloud providers these days. Netflix is just one example. aware of is the Amazon e-commerce website, right? The Amazon e-commerce website is also hosted on the AWS infrastructure, right? Now, a company, an e-commerce website better comes from a website, from online, being online, right? Imagine they are relying on the AWS infrastructure that all of you guys also have, access to, right? So imagine yourself, you're sharing the same infrastructure with the biggest e-commerce company in the so that your application is in safe hands, right? Another great example of cloud computing is Google Drive. So Google Drive is a cloud product. The Google Documents, the Google Drive where you can upload all your files and folders, they're all hosted on Google Cloud, a fantastic cloud product. Then we have Airbnb, which is actually a website which is hosted on AWS, and it's fully hosted on AWS for all its functionalities, scalabilities, and availability. Prime Video, which is video streaming service for Amazon, that is also hosted on. And the funny thing is Netflix, which is its biggest competitor, is also hosted on the same infrastructure as Amazon, right? Awesome, isn't it? So these were all the products that you see in your day-to-day life that are actually cloud products, and you won't even know whether they were on cloud or not. So now you know. Moving further, guys, now let's talk about the cloud computing models. What are the different kind of models that are in cloud that are there in cloud computing, and what are models? Guys, divided into two kind of models. The first model is the deployment model, and the second model is the service model. Get these two categories. Deploy on cloud has 3 ways to it, and the way you can access on cloud has again 3 ways to it. Putting your application out there. So if you're putting your application out there, you have 3 options. Cloud, private cloud, or hybrid. You again have 3 options, which is let's understand all these things one by one. Don't big words used here. We'll understand each and everything one by one, and then as you move along, if you have any questions, you can put it, right? So far, guys, I've not got any questions. I guess everything is crystal clear to everyone. So moving forward in the next slide, I'm going to start with the deployment model. So if you have any questions, now is the time, guys. You can ask me all out, and I'll be happy to answer it for you. All right. So as a question, and she said Netflix is, so that means all the videos that we see are also hosted on AWS. Yes, Shambhavi, all the videos that you see, the software itself, the website exists on AWS. Okay, so she has one more question. But when I install the Netflix app, it's available on my mobile. How is that on cloud? Okay, so Shambhavi, there are 2 sides to it. Netflix app, it's basically a client application. The videos that you get, they don't exist on the internet, right? So your Netflix application is just a client application, but it interacts with the AWS servers on which the Netflix servers have been deployed. All the videos that you see, there's a service called Amazon S3. All those videos, they exist over there, and they are basically provided to you using a content delivery network, which is basically nothing but a caching system. That is, I'll give you a very simple example, that if you are residing, let's say, in India, and you are watching, let's say, a US television show, so obviously that US television show is would be existing on the servers Netflix US, right? But if you are viewing in India, it doesn't make sense all the way from US your video, right? So the server has to be connected from the US to the Indian client app which is existing on your phone. That's a long way, right? And that's when the concept of latency comes in, wherein how does an application respond to your queries also depends on how far is the server from your application, right? So there's a service called Content Delivery Network, which basically what it does is it caches all the videos that you have to see or you're watching onto an Indian server if you are in India, right? And that's when, a server which is nearer to you has all the content which exists on the US server. And this is all on demand, right? So this is just very simple, a very small thing that Netflix does to improve its service using the AWS infrastructure. And this concept that I just told you is Content Delivery Network. Don't worry if you don't understand what I just told you. As we move along, I'm going to explain this in detail. All right. Any more questions, guys? Alright, so everybody is giving me a go. Alright guys, so if everything is crystal clear, let's go ahead and discuss the models one by one. So the first model that we're going to discuss is the deployment model. So what are deployment models? So guys, deployment models are nothing but the various ways using which we can deploy our application. Alright, now there are various ways. Let's look at those ways one by one. This is the first way of deploying your application on the cloud infrastructure is called public cloud. Now, what is public cloud? Public cloud are the servers which are offered by your cloud provider, in which each server can have multiple companies hosting their application. All right, it could be your Netflix, and it could be that your its competitor, that is Prime Video. If you have offered for public cloud, your application would share the same server as some other application. It could be Prime Video as well, right? So, but why is there a segregation? Although there is no problem when there are multiple applications on the same server, but what happens is some companies are still skeptic. Some companies have data policies that they say that we have confidential data and we cannot take any risk where some other companies also on our server, and there's a risk of our data being hacked into, right? So that's why, because of these data policies, there were different deployment models that were created. So like I said, public cloud is when the data that you're providing to the cloud is not that sensitive, is not that confidential, and hence you are okay when AWS tells you, although there will be no problem when a separate application is also deployed on the same server, there will be no harm to your data, and they say like, okay, anyways, we don't have any data policies like that, right? So public cloud is when you are using or the cloud computings or the cloud providers servers, and you allow them to host more applications on the same server. You're okay with that fact. All right, so that is public cloud. Next is private cloud. What is private cloud? Private cloud can be two things. The first thing is, like I said, if you want a separate server all for yourself, where you say, no matter how much space is empty, no matter how much of the server is free, I don't want any other company's data on my server. I want my data to be isolated. I want it to be isolated on this particular server that you have in your infrastructure. So that becomes a private cloud. The second way of creating a private cloud is you buy your own servers and you create your own cloud in your data center, right? That is, you buy all the stack of servers required and you host your application as if you're hosting on a cloud provider. It's just that it's your own cloud that you have created, right? You have bought your own servers and you're putting your data on your own servers. So that is private cloud. Okay. So the third thing is hybrid cloud. Now, what is hybrid cloud, guys? When you want to have a kind of infrastructure wherein you are using some of the public cloud and some of the servers from the private cloud, in that case, it becomes a hybrid cloud. So let me give you an example. Let's say there is a research company. So that research company, the marketing website for that research company exists on the public cloud, but on that marketing website also people have the access to log in, and when they log in they can see their research materials that they're working on. Okay, but this research material, it does not exist on the server of the public cloud. It exists on some other server which is private cloud. So from a user's perspective, I will say that it seems that everything is on the same website, but actually the infrastructure is like this, that the private cloud is or your sensitive or your research files are basically on some other server, or let's say the private cloud, right? And the website that you're hosting, which doesn't have that much of confidential data, is actually hosted on the public cloud, right? So this is a fine example of how a hybrid kind of architecture is created. One more example that I can think on top of my head is that let's say there's a company wherein it's been there since the past 15 years, right? So they have some legacy systems that they don't want to touch, which they have bought and on which the application is working. But what they have decided now is that any of the servers that we are going to launch from now on, any of the new applications that we are going to launch from now on, we are going to launch it on a cloud provider server, right? So in that case, what happens is these servers which were there in your data center, they have to be on the same network as the cloud provider's servers, right? That is a public cloud, and hence that kind of a mixture or that kind of a arrangement again becomes a hybrid cloud. So guys, these are all the cases wherein you can, or these are all the ways you can deploy your application on cloud. So first we discussed public cloud, which was basically when the servers, they can be shared between multiple clients of the cloud provider, right? And basically those servers are owned by the cloud provider. Second is private cloud, wherein there are two cases. The first case could be that you own or you ask your cloud provider to give you a separate server stack where no other data will be available, only your data will be available. That is one kind of private cloud. Second kind of private cloud is when you buy your own servers and you set up a data center and that becomes your own private cloud. That is also a way of creating a private cloud or using a private cloud. Third kind of deployment is a hybrid deployment, wherein you use some servers from the public cloud and you use some servers from the private cloud, and hence it's called hybrid. All right. So guys, any doubt in whatever we have discussed so far? If yes, please comment in the chat box or put your question in the chat box and I'll be happy to answer it for you. Any doubts, guys? If there are no doubts, we'll move forward. But if any doubts, now is the time that you can mention it and I'll clear it for you. Alright, so Shubham is saying, can you explain private cloud once more? Sure, Shubham. So private cloud is nothing but using a server which is not shared by anyone else, right? So how does AWS work, or how does any cloud provider work for that matter? They buy a very big machine or very big server with a lot of RAM and with a lot of processing power, right? And what they do is they launch multiple instances of virtual machines on it, right? So it could be that, you imagine your laptop, you can probably, if it's a i3 or it's a i5 with around 8 GB of RAM, you can launch around 3 operating systems on the same server at the same time using a virtual machine, right? You can do that. Now, similarly, what cloud providers do is they buy a stack of servers, and what they do is they launch multiple virtual machines on that server, right? And those virtual machines are owned by people who basically launch it through the AWS console or the Azure console or the GCP console, right? They launch it from there. Now, when your application or when your instance is up and ready, it is actually a part, or it's actually a virtual machine which is a part of a server. But it could be that same server is hosting 7 or 8 more virtual machines which are owned by other people who have created their Azure or GCP accounts, correct? So if that is the case, then there are some companies like, let's take the example of government agencies, government secret agencies, which or intelligence agencies like CIA or CIA in US, like Homeland Department in US. All of them, they have very confidential data which have to be accessed by their internal employees, irrespective of the fact where they are sitting and in what part of the world they are sitting. Right now, in those kind of cases, what happens is, although they can buy their own servers, they can set up everything by themselves also, but then, like I said, they'll have to hire a team also that will manage the servers. So what cloud providers do is they give you an option of having your own server stack which is isolated from the rest of the infrastructure of your cloud provider, right? That server stack is exclusively for you. It'll be a little higher, the price will be a little higher, but it'll again be on a pay-as-you-go model. That is, you can say that for how much ever time you'll be using it, for that much time only, you'll have to pay the cloud provider. So that is what private cloud is, that you get a separate isolated server for yourself on which you will be working. You will be putting your applications on it, right? And those applications will nowhere be connected to nowhere will be sharing the infrastructure which the other clients of that cloud provider are using. So that is private cloud. Other way of saying what a private cloud is, that you buy your own servers and you set up in a data center, right? So although in that case you're not getting the benefits of cloud computing, but yes, that also is called a private cloud because you buy the same kind of infrastructure, you buy the same kind of infrastructure at scale, at the same scale that a cloud provider does. You buy it at the same scale, right? When I say scale, in the same quantity, you set up a data center according to it and it becomes your own private mini cloud, right? That is also what a private cloud is. So, all right, I guess Shubham, now you're clear with the doubt. All right, thanks, Shubham. So others, if there is any doubt in whatever I've explained so far, please let me know. I'll clear it out. And if not, we'll move forward to our next topic. All right, so everybody is giving me a go, guys. So great. Let's move on to a next topic, which are service models. So we have discussed deployment models. That is what are the various ways in which I can deploy my application on a cloud provider. Now let's discuss the various kind of services that I can get from a cloud provider. Okay, so let's discuss that. So what are service models? Now guys, there are three kind of service models that we get in cloud computing. The first one is infrastructure as a service. Now what is infrastructure as a service? Basically, the cloud provider will give you an access to the server. That is, you will get an access to the operating system of the server, and you can install anything you want in that server, and that will become it can website server, it can become anything. So basically, when we say infrastructure as a service, you're getting the whole infrastructure, you're getting the whole system, you're getting the whole virtual machine as a service delivered to you. Right? So that is infrastructure as a service. Second is platform as a service. So in contrary to what we got in infrastructure as a service, wherein I got a machine that I could use, in platform as a service, I do not get the access to the operating system. Okay, what I do get an access to is kind of like a dashboard, wherein in that dashboard, I can upload any files that I want, and those files would automatically be put on the server by AWS, and I can see those files hosted on the server. If it's confusing, let me give you an example. Let's say if I want to set up a website and what I get is infrastructure as a service. So in that case, what I'll have to do is I'll get a fresh operating system. On that operating system, I'll have to install a web hosting software like Apache or Tomcat or anything. Once I have installed it, I will have to do an FTP, or I will have to transfer my files from a local computer on that AWS server using FTP. Once I've done that, I have to put those files in a specific folder on that particular server, and only then I will be able to access it when I go to the IP address of that particular server. This is the case of infrastructure as a service, where I've done everything that I had to do, right? In case of platform as a service, what happens is that I will not get the access to the operating system. All the softwares, all the settings that are required to be done is done by AWS. What I do get an access to is a dashboard where I have a button called upload. I click on that upload button, and what it will do is it will upload my website automatically. It will directly upload it to the location where it has to be. It will give it the required permission so that my website is hosted. So as a user, I don't have to get into the nitty-gritties of what kind of software has to be installed, what version of software has to be there. Everything is managed by AWS. I just upload my website and my website gets up and ready on a particular IP address. Okay, so this is platform as a service. It's basically an automated version of infrastructure as a service, where you get specific access on the server that you can just upload your files. There is nothing else that you can control on that server. That is platform as a service. The third kind of service that you get is software as a service. Right? What happens in software as a service is that, in contrary to what you got in infrastructure as a service, wherein I did not get access to the server, or where I got access to the operating system of the server. I could install anything, I could make that server anything, right? Second thing was platform as a service, where I got a dashboard where I can still upload my files, and those files will be hosted for me. Rest everything else will be managed by AWS or the cloud provider on which I'm taking this service from. Third kind of service is software as a service. Now, what is software as a service? You do not get access to a dashboard where you can upload your files. You do not get access to the server where you can do whatever you want on the operating system. What you do get is a software which has already been hosted on the cloud, and that software you can use. The straight away example for this would be Netflix. So Netflix is a software, correct? It doesn't matter which server it is on. It doesn't matter whether you can upload your files or not, but you can use the software which is hosted on the cloud. That is software as a service. Software has been provided to you by the cloud provider to use as a service, and that service is a pay-as-you-go service wherein you'll have to do a monthly subscription. Okay. Another example for this could be the Google Docs that you use. You use Google Excel, or you use Google Word, right? All of those are softwares which are hosted on the cloud provider, and you can use those softwares. It doesn't matter which server it exists on. It doesn't matter what kind of softwares are installed on that server. I just have one software that I can use, and it has been hosted on the cloud. So that is software as a service. All right. So this is all about the different cloud models which exist, which are offered to the customers, right? Moving forward, now let's talk about cloud providers. Now, whatever we have discussed so far is in general or is generic to cloud computing, right? Now, these kind of models or these business models that we just discussed have been adopted by various companies which are out there. Right, so companies like AWS is there. This is the most prominent one. Second is Microsoft Azure, and then you have Google Cloud, and there are 100 plus more companies which give you the same kind of services. Like another famous cloud provider which comes on the top of my mind is DigitalOcean, which is there, right, which offers the same services, just that the jargons that it uses for giving you that service is different. The terminologies would be different, but at the back end, it's doing exactly the same thing, right? So DigitalOcean is there, Joint is there, Telemark is there, IBM Cloud is there. There are a lot of cloud providers. But why have I just showed you these three cloud providers? Because these are the three top cloud providers in the industry right now which give the cloud services. Okay, I'll say 90% of the whole cloud paradigm is actually covered by just these three cloud providers. That is, people, if there are 100 people who are using the cloud computing in the world, out of them 90 people would be using a service among these three only. Okay, now today in this session we are talking just about AWS, but why are we only talking about AWS? Why are we not talking about the others? Let me walk you through the points.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So guys, the number one reason for AWS being so popular is that it covers 35% of the market share that is using the cloud computing platform these days. That means that if there are 100 people who use cloud computing, or if there are 100 companies which use cloud computing, out of them, 35 companies would be using AWS, right? So that's what the 35% market share means. Second reason is that AWS was way back incepted in 2006, and since 2006 I think it's been 13 years. So since 13 years AWS has been running the cloud computing business, and when AWS launched its cloud computing business, I guess it was the first and foremost cloud provider which went into the cloud computing domain and thought, okay, I can run a business on it. I guess back then there was no company which was providing the cloud computing services except AWS, and that is the reason, AWS has such a huge market share, which is 35%. If you compare it with Azure and Google Cloud, Azure is at 13%, and Google Cloud is at 6.5%, right? So Azure is a number 2 cloud provider in the world, and Google Cloud is at number 3. So you can just judge by the distance between this 13% and 35% that how huge AWS is, right? And Microsoft Azure has to do a lot of catching up to basically beat AWS right now. And the point that I'm trying to make here is that the reason for that gap is because AWS was launched way back in 2006, and Azure was, I guess, launched in 2012, followed by Google Cloud in 2013, right? So that is the reason most of the companies were already on AWS when Google Cloud and Microsoft Azure came into the picture, all right? So Microsoft Azure has 13%, Google Cloud has 6.5%, AWS was launched in 2006, and that is the reason AWS has a more mature model of infrastructure. Now, why is that? Because any company or any product that you launch, it always so when the first time when it's launched, it always has a lot of bugs to it, and it's as and when the companies or your clients start to use it, you get to know, okay, so this is also a problem, this is a problem, this is a problem that you have to solve, right? And when you solve it, your product becomes more mature. It becomes more reliable. And since it's been 13 years now that Amazon has been in the game, it has matured a lot. And when we compare it with Google Cloud or Microsoft Azure, they still have a long way to go. Already, although they have launched pretty good products, but they still are no match to what AWS has in terms of reliability. And that is the first and foremost reasons companies also have, they stick to AWS as their first choice, because most of the companies companies that they see, like we discussed, there is Netflix, there is Airbnb, there is Amazon e-commerce company, then you have Prime Video. All of them are on AWS and they're doing well, right? None of them has experienced any downtime being on the AWS platform. So any company who is trying to launch their product into the market, they also stick to AWS, reason being it's so reliable. Third reason that why we are learning AWS today, why you guys are learning AWS today, is because of the job opportunities. So because it has a greater market share, because there are more companies who are using AWS, obviously the job opportunities for AWS are also more, right? When you compare it with its counterparts, that is Google Cloud and Microsoft Azure. So like I said, if there are 100 companies and out of those 100 companies, if 35 companies are using AWS, that means 35 companies you can apply on to become a solutions architect, to become an AWS developer, to become an AWS administrator, a cloud engineer, anything, right? So it's always better if you want to get into the cloud domain to first get to know the major player, right? And then obviously you can also learn Microsoft Azure. Once you have understood AWS, it's very easy to actually understand the other cloud platforms like Microsoft Azure and Google Cloud, because they're almost the same. All of them are basically giving the same services, just that the jargons or the terminologies that they use are a little different. All right. Having said that, guys, let's move on. And now that we know that, why AWS is so successful, we understand that why are we learning AWS today? Let me introduce you to what AWS is. So guys, AWS is basically a subsidiary of Amazon.com, which is basically the largest e-commerce company in the world, right? So the way AWS came up in the market was that Amazon, the largest e-commerce company, was building the infrastructure for its website, right? And they designed an infrastructure which was highly scalable, highly available. It can autoscale itself, it can downscale itself. So all of these things were part of their architecture of the Amazon website. Now when they created an infrastructure like this, they thought, why are we only using it for our website? Why don't we make it available to the general public, and they can use it as long as they want in a pay-as-you-go model? And that's how the cloud computing model or the cloud computing business came into the picture, right? So the same infrastructure that it was using for its website, it made it introduced to the world to say, like, I'm hosting my website, or I'm hosting my Amazon e-commerce website on this infrastructure. If you also want your application to be as successful, as reliable, as available as my website, you can use the same infrastructure. And you know what? You just have to pay for the time that you used it, and the cost is as low as $0.0005. Isn't that amazing? So that's how AWS came into the picture, right? And now today it offers services in compute, it offers services in storage, networking, management, security, and many more that we're going to discuss as we move along. All right, so this is the AWS story, guys. We understand now that what is cloud computing. We understand now that the different kind of models that cloud follows. All of those things are followed by all the cloud providers. AWS is one of those cloud providers, and I told you the backstory of it, how it was launched, how it was incepted. And since it's the first player which came in the market, it's very matured in terms of its services. I think they have covered all their edge cases as to how our application can actually not be of use to a particular company or can fail, and they've covered all that. So you can be rest assured that if you are deploying an application onto AWS, it is in safe hands. All right, moving forward, guys, now let's talk about the thing that we are here to learn for. Let's talk about the AWS services. Let's see what kind of domains does AWS gives its service into. So AWS provides its services in compute, it gives in storage, database, security, management, customer engagement, app integration, etc. So we're going to discuss each one of them one by one as we move along. So first up, the compute domain or the AWS domain is compute. Alright, so I think I have a question from Shubham. So Shubham is asking me, among these domains, what is the difference between storage and database? Alright, Shubham, so storage is basically used when you have a workload wherein you want to upload binary files. Like, what are binary files? Files which like video files or MP3 files or photo files. All these files are called binary files because they're not data. It's basically, it's content, and that content is basically binary in nature. All right, so all your videos, all your music, right, any kind of file which you execute, your games, all of those are binary files. When you compare it with database usually deals with data which is textual in nature and has a proper structure. It could be unstructured as well, but basically textual data that a human can read is included inside a database, right? But on the other hand, files that run on computer, for example, any program or any video file, any music file, or any other file in that case, these kind of things cannot or should be stored on a storage kind of platform. It should not be stored on a database. It can be, but it should not be, because it unnecessarily makes the database, the size of the database big, which actually causes a problem when you're querying through the data when you're using a database. Alright, so guys, this is the difference between storage and database. Shubham, is your doubt clear about the difference between storage and database? Alright, so I've got a yes from Shubham. Others, guys, if you have any doubts in these domains, you can ask me. Let me explain you all these domains one by one. So compute domain basically deals with servers. So if you need servers, or if there is a workload which needs processing, the compute domain will have services that you can launch and implement that workload. More on this we'll discuss as we move along. All right. Then we have the storage domain, which, like I said, deals with storing binary files on the remote servers. So for that, we have a dedicated services, and we're going to discuss those dedicated services in storage. Then we have a service called database, a domain called database. In the database domain, you have a lot of services. So if you have structured data, you have one kind of database for that, or you have one kind of database service for that. If you have unstructured data, you have another database service for that. So we'll discuss more on that as we move along. Then there is a domain called security. So all security related to the application that you have uploaded, to the servers that you are using, to the account that you are using, for all those kind of things would be included in security. So there are specific services for each kind of workload that I just mentioned. We're going to discuss that when we reach the security domain. Then we have the management domain, which would include monitoring, which would include deploying the whole architecture at once, right? All those kind of services comes in management. Don't worry if you don't understand it. I'll explain you more as we move along in that domain. Then we have customer engagement. So sending emails, sending notifications, all those kind of services comes under customer engagement. And in the end, we have app integration. So services like queues, like for example, if you have an application on which you have to give a lot of jobs, it's better to have a queue where you'll store all your jobs, and that queue is separate from the server which will be executing your jobs, right? So these kind of integrations are called app integrations, and we'll be discussing the services in that domain as we move along. All right. So guys, these were the domains, the main domains that are there in AWS. There are a lot of other domains as well, but we'll be focusing more on these domains since, this is what is actually going to be asked for in your solutions architect exam. And at the same time, these are what you will generally be using when you become an AWS engineer. All right. So moving forward, guys, now let's start with the compute domain and let's see what all services are there in the compute domain. Alright guys, so let's discuss the AWS services in the compute domain. So here are the set of services which are included in the compute domain of AWS. So this particular service is EC2, Elastic Beanstalk, Lambda, Autoscaling, AWS Load Balancer, AWS ECR, and AWS ECS. Now for the sake of explaining you guys, I've taken the liberty of shifting some services from some other domains which I think should fit in this domain, right? But you don't have to worry, the explanation would be the same. It's just that you would find it somewhere else in the AWS management console. Like for example, autoscaling would not be under the compute domain. It would be under some other domain. I'll show you when we move on to the AWS management console as to where you can find each and every service.
Okay guys, a quick info. If you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
For now, guys, let's start with the first service, which is AWS EC2, and let's see what is it all about. So guys, Elastic Compute Cloud is nothing but a server. It's a raw server. It's just like a fresh computer that AWS gives to you. So what you basically do is you ask AWS for server, right? And that server service is called EC2. So what you do is you specify the kind of processor that you want, you specify the kind of RAM that you want, and then you click on launch. And what happens after that is you get a server which is basically of that exact configuration. Now what you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's a Windows machine, you will connect through RDP, right? And once you connect to it, it'll give you the UI of how an operating system actually is. If you installed it on your local, it'll be exactly the same. It's just that now it has been basically launched on the infrastructure of AWS, and that can be accessed using various tools like the RDP tools or SSH tools. I'm going to discuss more about EC2. I'm going to basically launch an EC2 instance in a moment. But before that, let's discuss all the services which are there in compute, and then we'll do that EC2 demo as well. Like I said, it's just like a raw server that is given to you. And on this raw server, you can install anything, you can make it anything, you can basically build it, make it a web server, you can make it a database server, it can be anything, right? That is what EC2 is all about. Now in the diagram, as you can see, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of launching, of creating a EC2 instance and then installing some softwares on it, and then you can launch multiple copies of that particular EC2 instance so that you don't have to launch, or you don't have to specify, or you don't have to install all the softwares all over again. You can create multiple copies of the EC2 instance again, right? And at some point of time, if you feel you want to increase the configuration of your system, you can also want to make it 16 GB. Even that is possible in EC2. And that is why the name is Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease the size of the instance configuration as and when required, right? So guys, this was about Elastic Compute Cloud, or that is EC2, right? Our next service is Elastic Beanstalk. Now Elastic Beanstalk, guys, is an advanced version of EC2. How is it an advanced version of EC2? In EC2, what you could do was you could just launch a server, right? And then you can install softwares on it. You can make it a database server. You can make it a web server. You can make it anything, right? With Elastic Beanstalk, you get certain restrictions on EC2, and there is a certain amount of automation involved. So what is Elastic Beanstalk exactly? Elastic Beanstalk basically is a web application server, right? You cannot install any other software on it. It is a web application server on which you can upload your website, and you don't have to install any software. You don't have to do anything. Like I said, we talked about what is infrastructure as a service and what is platform as a service, right? So infrastructure as a service is EC2, okay, where you get the whole server, you get the access to the operating system, etc. Elastic Beanstalk is platform as a service. So in this, what you get is a dashboard. You don't get access to the operating system. You don't get access to the softwares that you have to install on that server, right? Everything is pre-configured. All you do is you say that I need a PHP server. It'll launch a PHP server and it'll give you a dashboard where you'll have a upload kind of a button. You click on that upload button and you'll have to put or upload your website over there. So once you have uploaded your website files, they automatically go into the path where they have to go. And all you have to now do is just go to that IP address or the domain name of that particular Elastic Beanstalk instance, and you will be able to access your website. If you compare it with if the same thing you had to do on EC2, you'll have to first install the softwares, then you'll have to upload the file using FTP because there's no dashboard to upload it. So you'll have to download an FTP client, connect to the instance, upload your files like that in that particular folder. And then if you go on to the IP address of the EC2, only then you'll be able to access the website. With Elastic Beanstalk, what they did was, like, if you have a use case where you have to deploy a web application, you don't have to do all that manual stuff of installing the software, of installing or putting your files on the server. All you have to do is you have to open Elastic Beanstalk, select the environment that you want to deploy, and upload your website over there. That's it, right? So it's an automated version of EC2 in which you have certain functionalities of putting a website over there, but there is a limitation that only it can be a web application server, right? It cannot be a backend server for you. Elastic Beanstalk is only used to deploy your websites. Guys, remember that, because the next service of ours is a little different from Elastic Beanstalk, right? And it also has some limitations. Our next service is AWS Lambda. Now, AWS Lambda, again, guys, is an automated version of EC2. It's an advanced version of EC2, but with some restrictions. Now, what are those restrictions? It cannot deploy an application. You cannot upload your website on it, and it cannot host an application for you. What is AWS Lambda? AWS Lambda is basically just used for doing your backend processing. Now, what is backend processing, you might wonder. So let me give you an example. Let's say you have an image processing application. So what do? You have a UI or you have a website through which you can upload an image. And what that website does is it stores the image on its storage, and then it reduces the size of the image, right? And then you can download it again. Now, you might be wondering, this is one website, so ideally everything should be happening on one server in this case. But that is not the case over here, guys. So what happens is your web application is on a separate server. The processing happens on a different server, right? And AWS Lambda specializes in processing. Now, why is AWS Lambda preferred for processing is because when you launch a server, guys, you have to select the configuration that you want, right? You have to select the processor, you have to select the RAM. With AWS Lambda, you don't have to specify any configuration. You don't have to choose what server size should be for my application to cater to the workloads that are coming in. AWS Lambda, what it does is it sees what kind of workload it is being given. It automatically scales up if it has to in terms of its configuration, and then executes all your workload and gives the result to the server, which is the web application server, where it has to give the result. Basically, only processing happens on AWS Lambda to go on, right? And that is exactly what Elastic Load Balancer is all about. So Elastic Load Balancer, what it gives you is it will give you one domain to go on, or it will give you one IP address to hit on. You hit that IP address and Elastic Load Balancer will automatically analyze where to send the requests. So the Elastic Load Balancer constantly keeps a check on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy. If there is a server which becomes unhealthy, what your load balancer will do is it will stop routing traffic to that particular server, right? And it'll start routing server to your traffic to other servers. And this is the main job of Elastic Load Balancer, which is to distribute traffic among all the healthy instances which are out there, right? Also, one more important thing over here is, guys, if all the three servers are functioning in the healthy state, in what will it do in that case? So it will distribute the data equally among all the servers. Now you might be wondering, how will that help? So let's say I just have one server over here with around 16 GB of RAM and let's say an i5 or an i7 processor, right? So it will be able to serve a limited amount of users. Let's say there are 10 people, right? So who are there on the website. Let's say the server will be able to serve 10 people. Now what happens if there are 20 people tomorrow? In that case, you always have to plan ahead and you have to keep more servers in your group, so that, or in your architecture, so that if there is more traffic, my requests can go on the other servers, so that the load is actually decreased on the first server, right? So what load balancer does is it will never make one server max out on its performance. It will always distribute the traffic equally among all the servers, so that the processing or the overhead on any server does not go up and my application should not become slow, right? Now you might be wondering that how do I constantly keep a check on how much traffic is coming on my website and accordingly deploy servers? So that answer I will give you in my next service, which is AWS Autoscaling. So what is AWS Autoscaling? It automatically scales up the number of servers based on how much traffic is coming onto those servers. Now, how does it do that? You can set a certain threshold. Let's say there are 4 instances which are running on my architecture. So what I can teach autoscaling is that whenever the collective CPU usage goes beyond 80%, launch one more instance in the group. And the load balancer should now route the traffic to the new instance as well, right? So this is what autoscaling is. Similarly, when the CPU usage collectively goes below 40%, let's say, decrease the size of my fleet, decrease the size of my server fleet. So in that case, what I'll do is, at the moment the collective CPU usage goes below 40%, it'll decrease the number of instances in your autoscaling group, right? And that's how it works, guys. And the autoscaling service cannot exist alone. It always has to work in conjunction with AWS load balancer. Why? Because if the size of the fleet is increasing, if the size of the fleet is decreasing, there should be an entity on top of it which will distribute the traffic equally among all the instances, right? So if you are making use of autoscaling, you will always make use of AWS load balancer. On the other hand, you can just make use of AWS load balancer and you might not want to use autoscaling. That is fine. But if you're using autoscaling, you absolutely have to use a load balancer for your traffic routing. All right. So this is what autoscaling is, guys. Our next service is Elastic Container Registry. Now, what is Elastic Container Registry? For this, guys, you have to know what Docker is, right? So if I have to give you a brief about what Docker is basically a tool using which you can launch operating systems in the minimum size possible. So the minimum container size that I know of is 40 MB. So what you can do is, let's say we were talking about distributed computing, right? So in distributed computing, what happens is each of your server plays a different part in your application, right? So similarly, what we can do is we can launch containers. Now what containers do is they act as a virtual server, right? But they take the minimum resources possible. They take minimum space possible. Like I said, 40 MB is the size of a container which holds an operating system, right? So in those containers, you can deploy applications, okay? And these applications then run as if they were running on a separate server. They are isolated from the operating system on which the container is running. I'm sorry, guys, if I cannot go in depth of what Docker is right now because it's altogether a separate topic, but you can understand it like this, that it's basically a mini virtual computer that you can run in your system. And ECR service, basically what it does is it stores these containers in a repository. Like you have GitHub for storing code, you have ECR for storing your container images, right? For example, like I said, operating system 40 MB size, the image has to be stored somewhere, so it will be stored in ECR. Now, if you want to run those images, you have a service called ECS.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So what ECS does is it runs any Docker image on the AWS infrastructure, right? And it orchestrates it in a way so that if there is anything wrong with that container service can again be launched. Now, don't get confused, guys, with what we do in EC2. Now, you might have a question that I can launch multiple EC2 instances. In spite of that, why don't I launch just multiple containers? Because in that case, what will happen is you're still the machine on which the containers are running. That becomes node point of failure. That means if there is anything wrong with that machine, any number of containers which are running on your particular system will go down, right? So this is also a redundancy that you can make in your architecture, that you can also run applications on containers which are running on an autoscaling infrastructure. That is a machine on which Docker is running. But if the processing or if the CPU gets an overhead, and the CPU processing increases, you can scale your machines and you can scale your containers as well, right? So if it's a little complex for you guys, you can just ignore this service, which is ECR and ECS. It's only for those guys who understand what Docker is. So guys, ECR is nothing but it's a repository on which you can store container images, and ECS is nothing but a service to run your Docker containers. If you don't know, guys, what Docker is, I'll just give you guys a link after this class. It's basically a video for introduction to Docker. It's a half an hour, 45 minutes video. You go through that, and then again you can go through this recording wherein you can find a description for what ECR and ECS is, and that'll make more sense to you in that case. All right. So guys, we have discussed ECR, we have discussed ECS. Alright guys, so moving forward now, let's go ahead and do some hands-on. I think it's enough of theory for compute. Let's go ahead and launch some compute instances in AWS. Alright, so what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat-test, right? We'll click on continue. Then it'll ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give 1 2 3 4 5 6 7 8 9, and the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS, guys, is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS, guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right? So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have Ground Station, Security Hub, Artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications. right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. Alright, now what we wanted to do was we want to launch our first server, and for that there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2, so I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that, and now this link would basically open your EC2 dashboard. Right? So from here you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service, and that will be in the further sessions that we're gonna have. For now, just understand how to launch an EC2 instance, and for that you just have to click on this blue button which is here, which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. You have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay, so let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from, right? But the only server that is free for you would be t2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select t2.micro if you want to be under the free tier and not be charged. So just select t2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this instance belongs to is there. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add, or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is the message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being launched. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test-Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's a software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch your Putty software. Right, this is my Putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part. Now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH. Then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it will give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it will verify the key that I inserted and it will be able to connect to the Putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay. So you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this, right? T2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right. So let's name this instance as Windows. All right. And now in order to connect to it, this is the IP address that you get. Now just click on actions. So select the machine that you have to connect with. Once it's launched, you'd be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect. And this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator. And if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch. But this is the way you get the password. Okay. Now, if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here. Right. And once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I'll just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this PEM file will work. So I'll just enter the test intellipaat.pem. Remember, the PEM file will work and not the PPK. Let's click on open. And now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here, and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes. And now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything. Okay. So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard? Look for Elastic Beanstalk. right? So as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test. Okay. And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET, I can put my web app in Go, I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these were all the settings that you had to do, guys. Nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys. You will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. Alright, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kinesis, firehose, log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Auto-scaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, it was a file before and now it's an object. Object basically is at the back end. That is how you store a file, is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS, which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that your service is gonna fail. Otherwise, 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that AWS guarantees that your object will have. And obviously you can increase this SLA, this basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service, and for that I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket, and you will be able to host static websites in that case. Alright, our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS and you feel that you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture, where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next. Leave everything at default, and now let's just click on create bucket. Alright, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures, and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3? You want to archive the data, put it in Glacier? all those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here. Right now, if I select this file, I can actually see the properties of this file via this link. Right, here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm, and my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now if I go to the website, hit refresh, I can see the image over here. Now this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website, and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS management console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step, right? Leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright, guys, so my file system is now being created. Now remember, guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here, to basically connect to these two instances. Right now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here, and now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is the security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you'll be doing is you'll be going to networking, you'll go to actions, go to networking and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let's the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay, now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test 2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test 2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we have successfully discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It will make sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is it also takes care of any security patch which has to be applied on your database if you enable automatic updates. Right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB, or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is, under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server, or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens? Your server is again and again doing a query on the database using a particular query, that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is, they create multiple users with restricted permissions. Okay. So each user can have their own user ID and password, but basically they will be logging into the same AWS account. And that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS Management Console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you will have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now what is an application account? Let's say I have a website which can upload data to S3. Now how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is, you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise it cannot, right? So this is one of the the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means Key Management Service. So Key Management Service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation, then we have AWS OpsWorks, then we have AWS CloudTrail, and in the end we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay, so let's say I have launched two EC2 instances with a load balancer with in an auto scaling group which is connected to an RDS instance, which in turn is also connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region, I want to replicate it across multiple regions. So in that case also CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks, and what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say MySQL on, let's say 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the OpsWorks architecture, and then in that case it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening. And it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it. And then that log data basically you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now, what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now, what kind of alarm can it trigger? It can either email you or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay. Moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now, this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, you'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services basically, guys. One service is called simple notification service and the other one is simple queuing service. Let's see see what these services are. So the first service, which is Amazon Simple Notification Service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now, that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received, and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay, so based on the topics, the messages are filtered, and what you do is in the topics you will define which service to basically trigger, and based on that, those services will be triggered, and the services to be triggered are basically called subscribers. Okay, so guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay, what it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years, my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay-as-you-go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. All right. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get, for instance, is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS, which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS, which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this, basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS, or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right. So the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you are running is another free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect the service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free, and the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS.
Just a quick info guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So in any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team, and the second team is called the operations team. Right now, what is development team and what is the operations team? A developer is basically a person who develops the code, right? He would develop the code, and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he is sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operations system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system. Please check your code. It is faulty, right? But now the developer was furious. It ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps, right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking, and this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as we saw in lean methodology, where we have eliminated everything. We have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? And then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about waterfall, agile, lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles and hence releases software in even lesser days than or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for an year, what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool. It is not a software. It's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities. And if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now comes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you're operating the software or you release the software for internal employees to see whether the traffic when is it doing good when it holds when it's getting traffic onto it. Is it doing good when normal people are doing arbitrary tasks on your software? And then you are also continuously monitoring it to see if your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys is by automating this life cycle. Basically, that means that now the developer does not have to give the code to the ops guy. It'll basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps lifecycle actually works, right? So if you were to that infinity sign that we had, it if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developer's side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay. So this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this. Right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server. Now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN, right? Now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version and at the same time it also holds on to the previous version so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN, and continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another, and that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares and system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system. It is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we will get an introduction to all the tools which basically come together to create a DevOps. Right. So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay, so let's go ahead and start discussing these tools. with their respective stages. So the first stage that we saw was continuous development. Now continuous development is implemented using version control systems, like I told you guys, and in most of the companies, the most used version control tool is Git. All right, so Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project, right? So it is great for team collaboration. It is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage. Then we have continuous integration. Now you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment, and continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization, and what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system which can be run on any system. The only pre-requirement is that you should have Docker installed on it, right? Similarly, you have configuration management. Now configuration management, what is configuration management exactly? So say you have a computer, you have a freshly set up computer on which you have some operating system installed. Now if you want to test your application on that system, what you have to do is, you first have to install all the softwares on it, right? For example, like I said, you would need Docker for your container to run. You probably would need an Apache server. You would need Python, or all these softwares which have to be installed can be installed using configuration management without even touching that remote computer or that freshly set up computer. And that is possible using tools like Puppet and Ansible, more of which we will be seeing in our course as we progress in our number of modules. All right. Our next stage is continuous testing. Now continuous testing, as we learned, was all about creating testing suites which would automatically test your code once it gets built on your system, right? So all these automation testing suites can be created using the Selenium software, right? So we will be learning the Selenium WebDriver in this course as we move along, and we will see how we can create our automation suites in Selenium for testing our applications. Okay, so this was about continuous testing, and then next we have continuous monitoring, wherein your application is continuously monitored and the logs are created. Any errors are also monitored, right? So all of that is done using Nagios. So Nagios basically gives you a dashboard with all your services listed on it, and those services can exist on any system outside the network or inside the network, and all these services running on it can be seen on the Nagios dashboard. Okay, so it's a great tool for monitoring your application. It's a great tool for gathering user data or user activity data at a one-stop destination. Okay, so that is what Nagios is all about. And this brings us to all the tools. So these were all the tools that we will be discussing throughout the course, right? And this brings us to the DevOps Tools lifecycle. So you saw the DevOps lifecycle earlier, wherein you had a developer, and the developer was basically pushing code onto a version control system. This is a replica of that figure, and in this figure we have just replaced the tools with the life cycles. All right, so now what the developer does is he pushes his code to GitHub. From GitHub, Jenkins automatically detects that on GitHub your code has been changed. It pulls the code and pushes it onto the testing server, and it installs all the softwares required on the testing server, and the testing suite that has been built on the Selenium is already present on that testing server, right? So Jenkins pushes the code here, the code is built and tested over here. If it goes successful, Jenkins again pushes the code to production, right? And on the production server, Nagios continuously monitors it for user activity, how many users are logged on, what the users are saying about it. All of that information is saved inside Nagios, and that information can actually be seen on the Nagios dashboard by the development team, and they can make a plan for the next release, what all features they have to include, what all fixes they have to do, right? And once you do that, you again start on with your next release. So this is what you do when you are working with the DevOps tools, and this portrays the whole DevOps lifecycle that we have in a company, in any arbitrary company which is using DevOps.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Let us get introduced to Git, but before that, let us understand, why are we only learning Git? Why not some other tool, right? Like I told you guys, there are a lot of distributed version control systems out there. Why are we only learning about Git, right? So let me just compare it on Google Trends, and this is the result that I get. Right, so if I search for Git, Perforce and Mercurial, which are actually the top 3 distributed version control systems out there, you can see that the Git tool is the most famous among them all, right? So that basically means that if you learn Git, you have a high chance that you might land up in a DevOps job more if you know Git than Mercurial or Perforce, because Mercurial and Perforce, because the popularity is low, we can easily conclude that not much of the companies are using these two tools, right? So most of the companies are using Git. In my experience also, I've seen most of the companies do use Git, right? And that is the only reason we have included Git in our course, and that is the reason we are learning Git also today. All right. So moving forward, now let us see what Git is exactly. Right, so Git is a version control system. It's basically a software which falls under the architecture of distributed version control system, right? And it does the same things which any other version control system does. That is, it tracks changes, it keeps your files versioned, right? And because it's distributed, you have a local repository as well, and then you also have a remote repository. Now, in case of remote repository, you get a lot of options, guys. But in our course, what we are going to do is we're going to opt for a free option, which is GitHub, right? So you might know GitHub. GitHub is famous for all the open source tools which it hosts, right? So we are also going to work with GitHub, but for now we are going to just focus on Git. First, we're going to understand what Git is, and then probably later we'll see how we can use GitHub in conjunction with Git. All right. Our next session actually is going to talk about the life cycle of Git. So we have understood, why are we actually learning Git? We understand what Git is exactly, but we do not know how it exactly works, right? We know the architecture, but we do not know how it works. So basically, we've divided all the commands that you could be used frequently or you will be using frequently among these 4 domains, right? The first domain is about creating a repository. So we'll be discussing some commands which will help you create a repository in Git. Then we'll be dealing with commands which can help you make some changes in Git. Then we'll be dealing with commands which will help you do parallel development in Git. And then towards the end, we'll also be learning commands which will help you in syncing your repositories. Okay, so let's discuss each of these domains one by one. So let's talk about how to create repositories. Let's start from the scratch, right? So our first, whenever you start a project, the first thing that you have to do is you have to go to your working directory and you have to do some code or make some code, right? So the first thing that I'm going to do is, let me just switch to my terminal. Alright, so this is my terminal and I'm logged into an Ubuntu server. So what I'm going to do is I'm going to create a directory which is say called DevOps. Okay, so let me create a directory called DevOps and let me just cd into this directory. Okay, so I'm into this directory now. Let me just clear the screen. Now let us add some files. Say I add a file called nano let me add a file called 1.txt, okay, and let us say hello world in it. So this is our first file, okay. Now let me add one more file. Let us add a file called nano2.txt. Let's say hello from Intellipaat. Okay, so this is a file that we have added now. Let's save this file. Okay, so now we have two files which are there inside a folder DevOps. Okay, so this is not being tracked by Git as of now, right? But it is still our working directory. Now, for making it a Git initialized working directory, all I have to do is type in Git init and hit enter. Okay, and now we have an initialized Git repository in front of us. Okay, so this is how you can initialize a directory in Git. So now you have created a repository in which you have your code, which will now be tracked by Git. Let's come back to our slides. So this is exactly what we wanted to do. We wanted to initialize a Git repository, and we have done that. We have added some files in that directory. Now let's go ahead and see what our next command is. So our next command is about knowing the status of what are the files doing in that directory. Are those files saved in Git? What is the status of that directory? And the command for seeing the status of directory or the files inside it is the command git status. So let us quickly jump back to our terminal. Let me just clear the screen. And now if I want to see like if my files are being if my files are saved in Git, what exactly is happening with my files. So what I'll do is I'll just type in git status, and I can clearly see that my files are right now untracked. Okay, why are they untracked? Because I've not staged them yet. These are just files which the Git is seeing that they exist in the directory, but they have not been added to my file system yet. So this is what Git is telling me right now. Okay, and it is also telling me if I want to track these files, all I have to do is git add and then the file name. So I don't want to do that right now. So let us go back to our slide. So this is what git status does. It basically gives you a status of your repository or of your directory. What are the files which are in the directory? I mean, what is the status of those files? Okay, so we got the status. Our next command is about adding. Right, so basically we have made some changes to our file and now we want to add it into a repository, and for doing that all I have to do is just go back to my terminal and I'll say git add. I can either type in the name of the files, so say I want to track both the files, so I'll just type in 1.txt or 2.txt. You type this, or what you can do is you can just type in git add and then a dot. Dot means track all the files which are present in this directory. So I'll hit enter, and now if I do a git status, let me just clear the screen. If I now do a git status, I can see that my files are now being tracked. Okay, so my files are now being tracked. They are staged, right? So if you think about the life cycle, you were in the working directory. Now you are in the staging area. You have staged your files. You want these files to be saved in the Git file system. They're still not saved. They're still in the staging area. The next step is saving these files in the Git file system. And for doing that, the command is git commit. Okay, so how do you type in the git commit? You type in git commit, then you give a space -m flag, which basically means the message, and then you type in the message that basically would point to what you are basically doing in that commit. For example, in this case, since this is our first commit, we can simply type, let me just clear the screen, git commit -m. We can say this is our first commit, adding 1.txt and 2.txt. Okay, so this is what we do. We just hit enter, and now you can see that my files have been committed to Git. Okay, and now if I do a git status, now, you can see it says on branch master there is nothing to commit, working tree is clean. That basically means all the files which are there in this directory right now are clean. They are all saved in the Git file system, and there's nothing to worry about right now. Right? So now let's do a little experiment. What I'll do is I'll add one more file. Let me just create one more file, and let us name this file as 3.txt and type in test file inside it. Right? So now what happens? So if I do git status, you can see it will say that 3.txt is a file which is untracked in Git. Rest all the files which are there, it is not listing that because those are already saved in Git, and they are there's nothing changed to those files. Also, let us try by changing, the 2.txt file, which is not listing over here, right? So what we'll do, we'll just do a little change to it. Let me just add 1.2 over here. Let us save it and let me do a git status now. Let's see what happens. So if I do a git status now, it can see there is a modified 2.txt file and there is an untracked file which is 3.txt. Okay, so this is something what you get. So any changes that you do to a file, it will be reflected in the status of Git. Now if I want the 2.txt file to be saved, I have to stage it again and then I'll have to commit it. Okay, that is the only way I can modify the 2.txt file. Okay, so let's come back to our PPT now and let us go ahead and see what is our next command. So our next command is about syncing repositories. So now we have committed the files to our local system, but how do we make it available to the world, right? So for making it available to the world, the first thing that you have to do is you should have a Git repository. Okay, so let me just jump on to my browser and then I'll show you how you can create a Git repository. So just give me a second. Okay, so guys, you just have to sign up on GitHub, and once you sign up, this is how your page would look like. Now what I want to do is I want to create a new repository. So on your left hand side you will see a button called new repository. Just click on that, right? And now let's name a repository something. So let us name it as DevOps and hyphen course. Okay, so our repository name is DevOps course and the type of this repository is public, and let us just now click on create repository. Okay, so our direct repository has now been created, and now what I have to do is I have to copy this link. This is a HTTPS link, guys, so I have to copy this link. Let us copy this link, and now let's come back to our PPT to see what exactly we have to do. Okay, so now to add files to this repository or to push files to this particular repository, first I have to add it in my command line. Now for adding this repository in my command line, I have to type in the command git remote add origin. Okay, this is the command git remote add origin and then the URL to the repository. So let us do that in our terminal. So I'm here. So right now when I'll commit, basically my 1.txt and 2.txt will be saved. My modified 2.txt file and my 3.txt will not be pushed. Okay, so let us see if that happens. So now what I'll do is I'll type in git remote add origin and then the URL of my repository. So the URL is this. Let me copy that. This is the URL and I'll hit enter. So now my files or my origin URL has been added in my command line, right? It has been saved in this Git repository, my command line that is working on my Git repository. Okay, so now let's come back to our slide. So we have executed this command. Let's see what our next command is. So our next command tells us how to push files to my URL, right? So the command is git push origin master, and see guys, this is the output for your command. Now when you type in this command git push origin master, it will ask you for your username and it will ask you for your password. So let us do that. So let me come here and let me type in the command. So the command is git push origin master. Okay, I typed in this command. It is asking my username. Let me enter my username. It is asking my password. Let me enter my password. I'll hit enter, and as you can see, it is pushing the files, and now my files have been successfully pushed to my repository. Let us check that. Let us come back to our browser. Okay, and let us refresh the page. So as you can see, it just says 6 minutes ago the files were committed to the repository and now they have been pushed, right? And over here you can see the message of my commit, which was first commit adding 1.txt and 2.txt. So you get the message over here. Here are the files, so you can see the changes or you can see the content of the files as well. If you click on 1.txt, my 1.txt had the content hello world, so it's being reflected here. Similarly, if I want to see my 2.txt, I can see that it says hello from Intellipaat, right? So everything is here, everything seems to work fine. And again, what I can do is now if I do a git status, you can see that there are 2 files which have not been added. So what I'll do is let me first make let me add first the 2.txt file, that is a modified 2.txt file, into my git repository. So what I'll do is I'll type in the command git add 2.txt. Let me hit enter. So now this file has been staged. right? So if I do a git status now, I can see that this file is now staged, okay, but this is still untracked, so we'll deal with this later. Okay, so now I have a modified 2.txt file, and all I have to do is git commit, and now I'll specify the message as modified 2.txt. okay, so this is the message that I'm passing. I'll hit enter, and now my file has been changed, but these changes have now been done to my local repository, not to my remote repository. So if I come back to my browser and if I refresh, you can still see the file which was added .2.txt. It still says hello from Intellipaat, and it was committed 8 minutes ago, right? So it still is not added to my remote repository. Now to add it to my remote repository, all I have to do is git push origin master. Okay, I'll hit enter. It'll ask me my username. I'll provide the username and the password, and now my files are being pushed to GitHub. It has successfully done that, and now if I do a refresh over here, you can see that it says that 2.txt was committed a minute ago, right? And you can see the message over here. It says modified 2.txt, right? And this is exactly what we did. So we have added the second file as well to our remote repository. Let's add the third repository file as well, which is 3.txt over here. So we'll do a git add dot git commit -m adding 3.txt, and now we'll do a git push origin master. We'll give the username, we'll give the password, and now my file has been pushed. And now if I do a refresh here, I can see even 3.txt has been added with the commit message adding 3.txt. Okay, so guys, this is how you can push your files, or you can sync your remote repository to your local repository. Okay, so this was the command for that. Let's move forward now, and let's check whether this step I've already done. So basically you can see that I have now synced my local to my remote repository. I have as you can see in the browser. Okay, now let's go ahead and see what our next step is. So our next step is to basically show you guys how you can clone a repository. Okay, so this is when I have basically I have pushed my local repository to my repos repository. Now say you are another developer who wants to work on this code. Now how can you work on this code? All you have to do is click on clone or download and just copy this link. Okay, copy this link, go to your terminal, right, and let me create a folder, say test over here, and let me create a folder called test over here, and let me go inside the test folder. Okay, now what I'll do is I'll type in the command git clone, and I'll give the URL, and I'll hit enter. Now what it has done, it has successfully copied the directory over here. So if I do an ls, I can see that the directory has been copied, or my repository has been copied to my local. Okay, and the awesome thing about this is, now if I go inside DevOps course, the directory, now over here I don't have to basically add a remote origin, right? Because you have cloned the repository, so this directory automatically knows where, if I push any file, where it has to go. For example, if I create a file, say I create a file nano4.txt, I say test file for clone. Okay, I'll say that, and now what I'll do is I'll add this, I'll commit this file, adding clone file. Okay, I'll hit enter. So my file has been committed, and now I'll do git push origin master. I'll give the username, I'll give the password, and as you can see, my file has now been pushed automatically. Okay, so if I do a refresh here, 4.txt has automatically been added, and I did not do a git remote add origin even if I am in a different directory. Okay, now let me show you what I exactly mean. If I create a folder, say I create a folder called test. Okay, test exists. Let me create a folder called hello. Okay, and if I go inside hello, and if I do a git init, say I did a git init, and now let me say create a file called hello world.txt, Let me add any arbitrary text into it. Now if I do a git add dot, and if I do a git commit, and I'll say let's adding file. Okay, so the file has been committed. Now if I do a git push origin master, it'll give me an error. See, it says origin does not appear to be a git repository. Why? Because I'm in a separate directory right now. Okay, now if I do a cd, I go inside test, which was my first directory where I created all the files. So over here, if I do a git push, if I add a file, say, let me first pull everything. Okay, so because the git pull origin master. Okay, 1 second, guys. Okay, so I think this is now the repository. Okay, so the repository was DevOps. So let us go into inside DevOps, and let me just create, or let me just say git pull origin master. So this is the directory where we first created our code. Okay, let me hit enter. So now it has, as you can see, it has added 4.txt to it, because earlier we added in a separate folder, right? So now it has created 4.txt inside it. It has added 4.txt inside it. And if over here you can see I have not specified what origin is. It automatically knows what origin is. Why? Because DevOps is a git initialized repository. Okay. Similarly, when I said that hello is a git initialized repository, but in hello I'll have to specify what is the origin of that repository, right? But if I do a git clone, as I did in test, right, I went into test and I did a git clone of the DevOps course. When I do a clone, it automatically copies the parameter as well as to what my origin repository is. Okay, any files that I add, if I push it on origin master, it will know where exactly it has to go. Okay, so this is how git clone can be helpful to you. All right, coming back to our slides. So now we know how to clone a repository in Git. We also saw how to pull, files in Git, but let me show you again. So basically what we want to show you is that say you are inside this folder, DevOps course, which is the same repository as what you have. Let me just duplicate this session.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Alright, so this directory, which is DevOps, is pointing to the same repository as DevOps course. Okay, now if I do an ls here, I can see that there are 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. Similarly, over here I have 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. What I'm going to do is let me add a file from here. So nano 5.txt, and let me say test file. Okay, I've added it. Let me say git add dot. So I've staged the file. Let me commit the file. Test. Okay, I've committed the file. And now let me push the file to my remote. So I'll enter the username, the password, and now my file has been pushed. Okay, so if I have updated my remote repository, this local repository of mine will not get automatically updated. As you can see, it will not get automatically updated. If I do an ls over here, I can see there are 5 files, and if I go here on my remote repository, if I refresh, I can also see here are 5 files. But imagine this to be one developer and this guy to be another developer. Now this developer will not have the updated files till he does a git pull. Okay, so if he wants also the updated files which have been put on my remote repository, all he has to do is he has to type in git pull origin master, hit enter, and now the files will be updated in his system. Okay, so if I do an ls now, you can see that 5.txt file has now been added to this directory as well. Okay, so for coming back to our slides, so git pull helps you in updating your repository to the latest commit which is available on your remote repository. So that is what git pull is all about. And the difference between git clone and git pull is, like I told you guys, git clone is basically used when you want to copy the whole repository at your local system. But if you want to update repository when you're working in it, if you want to update all the files which are inside it, you can use git pull. In that case, git clone will not serve the purpose. Okay. Moving forward, now let's talk about branches. Now, as you can see, now we are talking about parallel development. Okay, and as we learned in our previous topics or previous sessions, that if you want to do parallel development, or if you want to assign code to multiple developers, you basically branch out, right? You create a branch in your repository and you assign that branch to the developer who would be working on the code. Okay, so let us see how you can create a branch in Git. So for creating a branch in Git, this is the command: git branch and then the name of the branch. Okay, so let us see if we can create it over here. What I can do is, let me just clear the screen. Okay, and let us say I create a branch which is something like this: git branch, and say I create the branch feature 1. Okay, so the branch has now been created. Now if I want to list all the branches which are there, I'll just have to type in git branch, and I can see there are 2 branches in my repository now. One is called the master branch and the other one is called the feature branch. Okay, now any developer who wants to work on this code can basically work on this branch, and when he feels that his work has been finished, he can basically merge this branch to master. And merging means that whatever code you have added to feature branch will also be added to the master branch. Okay, don't worry if you're not understanding as of now, you'll understand as we move along. Okay, so I have added a branch feature 1. Now if I want to delete a branch, again all I have to do is git branch -d and then feature 1. Okay, so it says deleted branch feature 1. That's it. Okay, so now your branch has been deleted. Okay, and this is exactly what we wanted to do. Moving forward, now if you create a branch and you want to switch to that particular branch, the command is git checkout. Okay, so now let me create the branch again, git branch feature 1. So I have created a branch, and what happens when you're branching? Basically the last commit of your master becomes the first commit of your feature branch. Whatever you have created, whatever branch you have created, the last commit of your master becomes the first branch of your branch that you have created. Okay, so for example, in my master you can see that there are 5 files. So now if I go inside, if I do a git checkout into feature 1, so basically now I have switched to the branch feature 1, and if I do an ls over here, you can see there are 5 files. Okay, now what I want to do is I'll add a file. Say I add a file 6.txt over here. Okay, and I say hello world. Okay, and what I do is I save the file, git add dot, I stage the file, and now I commit the file, added to feature branch. My file has been committed, and now if I do an ls, I can see there are 6 files now. But mind you guys, this is not on my branch manager. Now if you want to see which branch you are on, just type in git branch, and you can see you are on the feature branch right now. Okay, now what I want to do, I want to check if my master branch also has these changes. So what I'll do, I'll just switch to my master branch, git checkout master. I'm on my master branch now, and if I do an ls over here, you can see that the 6.txt file does not exist here. Okay, reason being, my feature branch is isolated from my master branch. Whatever changes I'm doing on my feature branch, it will not get reflected on the master branch, whatever I do. Okay, and whatever I do on my master branch will not get reflected on my feature branch. It works vice versa. Okay guys, so this is a feature which you basically use when you want to do parallel development, so that no branch is it is interfering with each other. So now I don't care what my developer is doing on feature 1. When he says that the feature is complete, I'll ask him to show me, and when he shows me the feature and I feel it's right, what I can do is I can merge it with my master so that it becomes available to the world. Okay, all right, great. Now if I do a git status here, git status, one second, git status, it says on branch master, nothing to commit. If I check out to feature, yeah, so if I have switched to feature now all I have to do is I will type in git status, and it again says on branch feature 1, nothing to commit. Why? Because I've already committed 6.txt to it. Now what I want to do is I want to push these changes to my remote repository. So what I can do is git push origin feature 1. Why? Because now we are pushing the feature 1 branch. We are no longer pushing the branch, the master branch. We are pushing the feature 1 branch, right? And I'll hit enter. So it'll ask me the username. I'll hit that. And it'll ask me the password. I'll put that, and I'll hit enter. And now you can see my files are being pushed. And now you can see that feature 1 branch has now been pushed to feature 1 branch of my remote repository. So if I go to my browser now and I refresh it, you can see the 5.txt is still not visible here. Why? Because I'm on my master branch. I'll click here. I can see that I have a feature 1 listed over here. I'll click on that, and now I can see that the 6.txt file is visible here, and with my commit message which was added to feature branch. Okay, so I can again switch to my master branch, and I can see that my master branch is clean. If I switch to my feature branch, I can see that my feature branch is having the 6.txt file. Okay, let's come back to our slides. Alright guys, so we now know how to switch to a particular branch. Now let's go to our next slide. Now we probably know all the commands through which we can probably start working on Git, right? This command is a very important command, which is git log command. Now what is git log command? Now git log command helps you to see the history of your repository, like what all have you done on your repository. Okay, now to see the history of your repository, the command is git log. Now let us go back to our terminal and let us just clear the screen. Now if I do a git log here, I can see the history of all the commits. Okay, so I can see that I am on my head is on the feature branch right now, right? And I can see that the last commit was this, when I added 6.txt to the feature branch. Before that I had a test commit. Before that I had a clone file that I added. Before that I had some other commit, 3.txt, 2.txt, right? So similarly I get everything. I get a history of everything that I've done so far, right? And these are all the commit IDs, guys. This is what we studied earlier, right? So if I want to say revert to this commit, all I have to do is just copy this commit ID and I have to type in git revert along with this ID, and I'll be able to revert to this particular commit. But we'll do that later. We're not doing that right now. We'll do that later. But this is the history of your branch. Okay. Now if I want to see the history of master, this is the history of feature 1. Okay, let me just clear the screen and let me see where I am right now. So I'm on feature 1. So if we go to git checkout and then master and then clear the screen, if I do a git log over here, you can see that the head is now on the master, and only the log of the master branch I'm able to see right now. Okay, I cannot see the log of adding the feature file. Why? Because I'm on the master branch now. So whenever you do git log, you always see the log of what branch you are on. Okay, so right now I'm on the master branch, and that's why I can see all these logs. If I am on the feature branch, I can see all the logs of the feature branch along with the logs of master branch when the branch was when basically the moment I create a branch in my repository, it gets created from the master branch, right? So say I did 3 commits before I created a new branch. Those 3 commits will also be a part of my new branch that I've created. And if I go inside that branch and if I do a git log, I would be able to see those 3 commits in the log as well. Why? Because those 3 commits are also a part of those of that particular branch. Okay. So, but the moment I do any other commits on master, those logs of that commit will not come in my feature branch. Reason being, now my feature branch is separate. Alright. So I hope this is clear. Alright. Coming back to our slides, guys. So we now know how to see the history of our our Git operations. Our next command deals with git stash. Okay, so what is git stash? So whenever you're working with multiple branches, there could be a point where you don't want to basically commit the file is basically still not complete, right? But you want to switch to another branch because you want to probably fix something in some other branch where you're having a problem, right? So basically it's about multitasking. It's about putting on hold the work that you're doing right now, completing the work over there, and then coming back here again and then starting with your work, right? So let me exactly first show you why do you need the git stash command. Okay, so if I'm over here right now, let me just clear the screen. Okay, so let us create let us see where we are right now. So if I do a git branch, I can see I'm on the master branch right now. Okay, so what I want to do is I want to create, or let me just switch to my feature 1 branch, and let me create a file called 7.txt. Let me name it as stash file check. Okay, so I have created a file, but this file is still not staged. It is not committed yet, right? So I am on my feature branch right now. So if I do an ls, I can see 7.txt is here. Now if I change my branch, what will happen? Let us see. So if I do a git checkout master, and now if I do an ls, you can see the 7.txt file over here. Why can you see the 7.txt file? Because this file is not being tracked right now. It is not a part of any branch, right? Because it has not been saved yet, correct? So what I can do, so let me just come back to my feature branch. What I do, I'll just add, or I'll just stage this file. So let's see what then happens then, right? So I'll do a git add dot, right? And now the file has been staged, but it's still not committed, right? So if I do an ls now, it has all the files. Now if I check out to my master, and if I do an ls here, I can still see this 7.txt file. Now this can become a problem, or this might cause a confusion when you're working within branches or when you're working with production code, because you don't want this file to be here when you're on the master, right? Because you don't want your code to go haywire or cause a problem because of an extra file, or probably you changed something in 5.txt. Let me give you an example. Let me check out to my feature 1. Okay, and let me go to 5.txt. So this is my 5.txt, and it's there in the master as well. Let me change the contents of this file. Okay, so I've changed the contents of the file. I'll stage it. Okay, and I'll do a git checkout master. Okay, I'm on my master branch now. I'll do an ls, and now if I do a cat of 5.txt, can you see these changes are also there in the master? I don't want that. I don't want that to be reflected over here, because my feature branch should be different from my master branch. Now to avoid this confusion, although this file is it's not saved on the master yet, right? It is just being reflected over here. Reason being, these files are not committed to your branch in your respective branch where you were working. Okay, so how can you avoid this? Now the way to avoid this is you would just check out, or you would just check out to your feature branch where actually you want this file to belong. Okay, and it tells you that these 2 files are there which this has been modified and this has been added. Okay, so it gives you a notification, which is good. Now what you'll do is you'll say git stash. You'll just say this and hit enter. Now what will happen? Now if I go to my master, git checkout master, okay, and if I do an ls, I can see the 7.txt file is no longer visible over here, okay. And also if I do a cat on 5.txt, I can see this is the original file that the master should have, right? Now say I wanted to do something in my master branch. I'm done with that work. Now I want to get back to the work that I was doing in the feature branch. So what I'll do, I'll just do a git checkout feature 1. I'm back here. I'll do an ls. So right now the files will be not saved. So if I do a cat.5.txt, it will still be the test file. It will still show me the committed version of the file. I mean, if I want to restore the files that I was working on, all I have to do is git stash and then pop. This is the command to basically come back to your working state. So I'll hit enter, I'll clear the screen, and now if I do an ls, I have 7.txt, and if I do a cat on 5.txt, I can see this is the modified 5.txt. So I'm now again in my working state. If I do a git status, it will show me that my files have been staged, but then they have to be committed now. Okay, so now all I have to do is I'll say git add dot, and now I'll commit these changes, committing stashed changes, and now these changes have been committed to my feature branch, right? And now if I do an ls, if I do a git status, I can see that my branch is clean, and I can now easily just go back to my master. I don't have to stash anything anymore. And if I do an ls, it is still isolated. Reason being, everything is committed to the branch now, and there is no dangling files here and there, which could confuse me with the files that I'm working in whichever branch I want. Okay, and this is why we use the git stash command, so that we don't have any confusions. The files don't get mixed up with the files of other branches, and we don't get confused. Okay, so guys, this was the git stash command. Let's see what our next command is. So our next command is git revert. Okay, so this is an awesome feature of Git. So let us come back to our terminal. Okay, so what I want to go do is I'll just do a git log, and I have all these commits over here, right? So I want to go back to my first commit where I just had my 1.txt and 2.txt. Okay, I want to go back to this commit. So all I have to do is I'll just click, or I'll just copy this commit ID, right? I'll clear the screen. I'll do a git revert, and I'll just paste that commit ID, hit enter. Alright, so let's go back to our terminal. Alright, so now for doing this, let us first see where we exactly are. So we are on the feature 1 branch. Awesome. So now we want to revert the changes, right? So for reverting the changes, the first thing that you do is you see the log. So right now the logs is that the last commit that was made, on which the head is right now, is this commit where we added these stashed changes. See, this caused a problem in my code, and I want to revert this. So I want to revert this commit. So whatever changes I'm doing in this commit will be undone, right? Now for doing that, all I have to do is I'll copy this commit ID, okay? And before just doing everything, let me just do an ls, and I can see that I have 7.txt which I added in my stash changes, right? So what I'll do is I'll just do a git revert, and I'll paste the commit ID, right? So let me just take the commit ID from over here, done, paste it here, hit enter, and now you can see it will say your 7.txt will be deleted, and we modified 5.txt, remember, right? So my file which was modified 5.txt will also be reverted. So these will be the changes which will be committed once I revert from this commit. So I'm like, okay, so I want to do this, so I save it, and now if I do an ls, I can see that 7.txt has been removed, and my file also which I had modified has now been changed, and you can see the changes over here. So that 2 files have been changed, 1 insertions and 2 deletions, and this is it, right? This is what just happened. And if now I do a git log, you can basically just see that when I did git revert, it basically committed a new thing on my feature 1 branch. It committed a new file on my feature 1 branch with the message revert of committing stashed changes, right? And it says this revert commits 9A6090. So basically it undid the changes which I did in this particular commit. Now if you still want to go back to this commit and see what changes have actually been done, what you can do is, if I want to go to this commit, all I have to do is just copy this commit ID, and now I'll type in git checkout and then the commit ID. Okay, so now I'm in the stashed commit, right? So now if I do an ls, I can see that 7.txt is present, right? Now what I want to see is what all things did we modify. I think we modified 5.txt, so let's do a cat on 5.txt. So I can see it says test file 12, and here is my 7.txt, which if I do a cat, it will say stash file check. Okay, now what I'll do is I'll say git checkout feature 1, so it will again return to the latest commit on my feature 1 branch. So I'm returned now. If I do an ls, I can see that 7.txt file is not there. If I do a cat on 5.txt, I can see that it has again returned to test file. So my changes which I did over here, that is, I changed file in my commit of stash changes, that is, I changed the file content to test file 12, and I created a file called 7.txt which I had stash file check. I had reverted this commit, and reverting means undoing the changes that you did in that commit, right? And it undid the changes that I did in that commit. So I no longer have 7.txt which I created, and I no longer have the contents of 5.txt to be the same as what was there in that particular commit. Okay, but remember guys, you still have that commit in your logs, and if you want, you can go to that commit and see what all things you want to fix, right? It's right here. But the head of the feature branch has now changed to a new commit, which basically has undid changes or undone changes of what was there over here. Okay, sounds great. So this was all about git revert. All right, moving forward, the next command is git diff. Now git diff basically helps us in understanding what all has changed, right? What is the difference between two files, or what is the difference between two commits? What are the difference between two files? You can all see that using the git diff command, right? For example, if I come back here and I want to see the differences between what I did over here and what I did over here when I actually committed the stash. So we can do that. Let us see how we can do that. So I'll type in git diff, okay, git diff, and then I'll type in this commit ID, which is my head right now, and this commit ID, which I basically reverted. So I hit enter, and it will tell me that what all did change from both these commits, right? So it says that you have modified 5.txt. So there are two versions of 5.txt, a/5.txt and b/5.txt, right? So the a file was deleted and the b file was added, and it also shows the content, what content was changed and what content was added, right? So if I am comparing the head with my previous commit, it says basically this file was changed and this file was added, right? And if I see over here, it says that there was nothing before and then we added 7.txt. Okay, now if I do the same by reversing the order of the commits, let's see what happens. So what I'm going to do now is I'm going to say this is the commit which I want to check the difference with this commit. So now you can see that it says that test file 12 was removed and test file was added. Similarly, 7.txt was removed and null was added. Okay, so basically this should be your newer commit and this should be your older commit, and then it will tell the difference according to that, right? Similarly, if I want to do this, so I want to first check if everything is fine. So let me do a git status. Okay, so everything is committed on my feature 1 branch. What I'm going to do is I'm going to change something in 4.txt file. Okay, so what I'll do is I'll do a git I'll do a nano 4.txt, and let me change the file content to test file for diff. I'll save it. Okay, sorry. So, alright. So let's call this file as test file for diff. I'll save it. Okay, the file is now saved. I'll do an ls. So now my 4.txt file has changed, and I can see that in git status. Okay, but I want to know what exactly changed. So what I can do is I can do a git diff with my head. So head points to the committed version of my branch, and I want to check what is happening currently, right? What is the current current in my current directory? I have not committed, or I have not staged the file for changes, right? My current directory is different from what is committed on the git file system. So that is what I'm comparing right now. I'm comparing my committed my latest commit with what is there currently in my folder, that is dot. Okay, I hit enter, and you can see it says that there is something which has changed in the 4.txt file. So there was test file for clone before, which now has been changed to test file for diff. And this is exactly what I wanted to check. So git diff is basically used to check the differences between two commits or two files. Okay, and this is exactly what we have checked right now. Awesome. So let us come back to our slides. So guys, this brings us an end to all the common Git commands that you could be using in your day-to-day life while you're using Git, right? In our next class, we are going to discuss the most important topic of Git, which is merging, right? Now, before going on to the next slide, I would request you guys, you practice all these commands once on your own. You will understand how things are actually working behind the scenes, right? I've showed you the syntax, I've showed you how it works, I've showed you the results. I want you to practice on your own as well.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
So guys, Docker was essentially a need which came out of the problem that we're going to discuss just now. So imagine yourself as a developer, and probably you're just creating a website on, say, PHP, right? So if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else. Right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code, right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system, right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base, etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine in my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. If you think about it, it was actually nobody's fault, right? The operations guy did what he could in the best of his ability to replicate the environment, but it didn't work out. Now, you guys might argue that why don't we, use VMs in this case? Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? That is a viable solution. But the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? In that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it will become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable. We needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not. Right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now, once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you've installed the container engine, you can run any type of container that is there in the repository on the or on the web, which is available. For example, if your code needs an Ubuntu container, right? All you have to do is write Docker run Ubuntu, and what would it do? It would basically download the Ubuntu container. Then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, that it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay, so if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software, and on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries, and on these, you basically just put your code. in my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay. So this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it. Right, so you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system, and this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present, but in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Alright, so because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we have, we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. Alright, so guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss, so we have understood why do we need Docker, and we have understood that what Docker is exactly. Right, now let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on, you could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to, go along with the video as we are performing the hands-on. Alright, so if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac. And once you have the Docker toolbox, it'll basically install everything. It will install Compose, it will install the Docker software, it will install the other components of Docker. So you don't have to worry about what component is what. But basically just go to this particular link, download the Docker software. And once you have the Docker software, just come back to this CLI and just pass the command Docker version. And if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just again, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. Alright, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. Right, so if your internet is fast, it will hardly take a minute to install Docker, and once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker -version, and as you can see that the Docker version is 18.061 CE and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. Alright, so we have installed Docker on our system, guys, and I hope you guys are also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back, because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on, so that you get the maximum knowledge possible from this session. Alright, so the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. Alright, so basically this is how this is the whole lifecycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed, and basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. Right, so you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, that is again a lifecycle state that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the lifecycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically, I would say, a summary of what happens inside Docker. But of course, there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common, the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now, and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right. So this is the first command that we can try out when we are working on Docker. Alright, so whenever you want to find out what version of Docker that you're working on, you can simply pass this command, Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal because I feel that this color is a little dull. So that it becomes better for us to see. Just give me 1 second. Alright, much better. So when we pass this command, Docker version, you get the Docker version, the current Docker version that is installed on your system, along with the build name. And this is exactly what this command does. Alright. The second command that you can go ahead and try is Docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. Alright, so and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. Alright. Okay. So we'll type in docker pull and then the image name. So this is the image name, and we'll hit enter. Alright. So sorry about that. I forgot to use sudo. Alright. So sudo docker pull ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that. So sudo docker images, and then you would be able to see the image that you just downloaded. Okay. So this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on is, I think, around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run, and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is -it, which basically means make the terminal interactive. -d, which means run the container as a daemon. Run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what -d does, right? So the command would be sudo docker -it. It means make the container interactive in the terminal so that I can also pass in commands. -d, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see docker ps would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container. Right, so this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run -it -d and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this, I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago. And this is the container which has exited, which we manually stopped. And we can see that also by passing the command sudo docker ps -a. Okay. Now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now, if I want to get inside this container, the command for that would be docker sudo docker exec. So exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right. So if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space. Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet, right? So if you have the stopped the container but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the lifecycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps -a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. Alright, moving forward. Now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID, and this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right. So this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. Right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account. And as you can see, I have some personal containers that I uploaded over here. And I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step mean? So this step basically means that if I am on my system and say, I run my Docker command. Now say I run a Docker container. Right. So this is basically download and run the container for me. So sudo docker ps. This is the container that I want to go into. Alright, so I'm now inside the container. Now what I want to do is let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container, Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm-f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm-f and then the container ID, and this would remove your container. Alright, so I've deleted my container now, and if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
And if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. Alright, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container, and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. Alright, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now. Right, I'll just exit the container, I'll do a sudo docker ps. I can see this is the container ID, so I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. Alright, so with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. Alright, and now I can run a container on the image test, and all I have to do is sudo docker run -it -d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present, and this is how you can create a custom container. So I, for demo purposes, just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. Alright, and this is how you save changes to a container. Alright, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it, and once the Apache is installed, we're going to save that container into an image. Alright, so let's see how we can do this. So let's clear the screen. Let's exit this container, And let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than five or more than three containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command that is the sudo docker ps -a and then -q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. Alright, so this is the shortcut that you can use while working with Docker. Alright, so my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. Alright, so my container is now running. The next thing that I have to do is install Apache server on this container. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. Alright, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running, so let's start the service. So service Apache 2 start, hit enter, and if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now and let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. Alright, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit, give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID / and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID / your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshr/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, this is hshar/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80, right? So on containers port 80, Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container, this is the command to do that. -p space port number that you want to specify, colon the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshar/apache. Alright, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container id bash, and if now I do a service apache 2 start, it should basically give me either an error that apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. Alright, so let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter, and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server, it is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. Alright, so for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this id, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. Alright, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys, and the first thing that you would have to do is you would have to log into your Docker Hub from your console, and to do that you will have to type in the command sudo docker login, pass in this command, you'd be asked the username. So pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar/apache. This was the image name, right? That we gave to our custom container image. Hit enter and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo and you'd be able to see your image listed over here. Just do a refresh and just go to the last page and you can see this is the image that I just pushed to the repository, which is hshar/apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push and that should be it. All right. So our next topic now is introduction to DockerFile. And let us go ahead and learn what is DockerFile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container and then how to do some changes to the container and save it on your local system. And finally, how to push that container onto a Docker Hub. This is what we have learned.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, the next step is what is a Dockerfile? So a little introduction about a Dockerfile. So you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this. When you're working on production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Dockerfile, right? So we're going to discuss what a Dockerfile is now. So let's go ahead and start with this topic now. So a Dockerfile is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Dockerfile. Now, a Dockerfile is very easy to write. And there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it will only be Dockerfile that you would be using rather than doing everything manually. Alright, so let's go ahead and see how we can create a Dockerfile. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Dockerfile. Now, the first line of a Dockerfile is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it -d and then Ubuntu. So in Dockerfile, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area of your presentation will basically tell you the Dockerfile content. So this is exactly how the content of the Dockerfile should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt get update and apt get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Dockerfile, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt get update and the second is apt get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Dockerfile, it would not ask that option and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run any command that you want to run at the start of the container. Alright, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker and -it-d and then the image name. Now after the image name, you can also specify a command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the Dockerfile, this command will be running when we are starting the container. Otherwise, whatever command we specify in the docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service Apache 2 start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd Apache CTL -d foreground would do nothing but run Apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. cmd is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the Dockerfile. Alright, the next command is entry point. Now entry point is exactly the same as cmd, that is it runs at the starting of the container, but the only difference is cmd will not run if you specify an argument in docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. Alright, so CMD and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. CMD command will get skipped if you specify an argument after the Docker run command. Okay, so in our case, we use the Apache CTL-D foreground with the entry point command. Alright, the next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. Alright, so in my case, I specified a variable name which has the value DevOps Intellipaat. Alright, so these are some of the commands that you can use to create a Docker file. Now let us create this Docker file on our system as well. So what I'm gonna do is I'm gonna go to my putty software and I'm gonna specify nano and then DockerFile. So let me just create a directory first. So let me create a directory called DockerFile itself. So mkdir DockerFile. Let us go inside it. So cd DockerFile. And now whenever you are creating a Dockerfile, the name of the file always has to be DockerFile itself, right? So I'll specify nano and then DockerFile. We went inside. So the first thing that we want to do is we want the Ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y. Install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground. That is, run it. So Apache CTL -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html, and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Docker file and we have the HTML page in place. So the next step would be to build this Docker file. Now let's see how we can build it. So for building this Docker file, all you have to do is docker build. Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as say new underscore Docker file. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo user mod -a-n-g and then docker and then $user. Enter, and now all I have to do is just re-log into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the DockerFile. Okay, and now I want to build this DockerFile. So docker build dot -t new _ DockerFile. So you can see the DockerFile is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new _ DockerFile. So let us run this new _ DockerFile. Docker run -it-d. Also let us specify the port number. So let us open it at port 84 and then -d new _ DockerFile and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84. And you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container or not. So we named it as 1.html, and yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec -it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my Dockerfile. So the first thing that we did was apt-get update apt-get -y install Apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the 1.html file has been added, and at the same time dockerfile was also added. So inside the directory we had these two files, right? 1.html and dockerfile. So both of these were added inside the container. Now to not have dockerfile inside your container, what you can do is instead of dot, specify // and 1.html. That would solve this problem. It would only add 1.html in the container. Okay, so it added 1.html, and index.html is basically the default page of Apache that you see, right? So we added 1.html, so this was added by the Dockerfile. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the Dockerfile. I specified the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Dockerfile in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a Docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a Docker push, and you should be able to use it. But I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. Alright, so let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. Alright, moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. Alright, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore. Right, so that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What you do, you delete the container and you launch it again. But with that, what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. Alright, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now, what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this DockerFile directory, right? So what I can do is I can map this DockerFile directory inside a container. Now to mount this particular Dockerfile folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the location of the directory, which is /home/ubuntu/dockerfile. Now this is the location of my folder, and then what is the mount point of inside my container. So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter, and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session, let me just duplicate this session. So I'll just go inside the directory DockerFile, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory /app in the container. Alright, so this is called bind mount. But there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container. Right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home/ubuntu/dockerfile is not going to exist, and that is where it is going to give you an error and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about say a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system it will be a little different. For Windows it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the Docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount it is a little difficult to basically migrate the data. In volumes it is very easy. You just take the volume up and then just put it on some other system and it will work. But in case of bind mounts, you will have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume. Right? So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay, so this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. Alright, so the next thing that I have to do is basically I'll have to type this command docker run -it -mount. And so basically if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount. Source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app, right? And then -d, and then the image name. Alright, so once the container is launched, now what we can do is we can go inside this container to check if everything is working fine. And we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then one.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session, and what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it will all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new_dockerfile. Okay, so what I'm gonna do is I'm gonna launch docker run -it, and then source, say, is equal to let me create one more volume, docker volume create, and let us create a volume for Apache. Okay, now what I'm gonna do is I'm gonna launch docker run -it, and then -mount. Source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this -d new_dockerfile. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec -it, and then this container, and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache, and target would be, say, /app, and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now can you see the files over here are same as what was there inside this container, var/www/html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory, okay, and what I do is I create nano do.html. I create a file and then I specify that HTML body h1. This is the new HTML file. Close the header, close the body, close the HTML, come out. Okay. Now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp ./2.html and then /var/www/html and then the container ID. /var/www/html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new _dockerfile container, docker rm-f, delete. Okay, so ideally, if I now launch a new docker run -it -mount source is equal to Apache, target is equal to /var/www/html. Okay, and -p also we specify that we want 81 port to be exposed, and -d and then the image name new _dockerfile. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new _dockerfile. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address but on page 82, you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the Docker file, right? For volume, we have it attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome, guys, we have successfully understood what Docker volumes are.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
And then, so why AWS for DevOps? What are going to be the benefits of using DevOps on AWS? So the first thing is fully managed services, guys. So we know why do we use a cloud service? Because we don't want to manage
our tools or the VMs we have launched, the data we have stored. We don't want to manage it, or we don't have to install softwares on it. We don't have to do anything. It is all taken care by AWS. They take care of our infrastructure. So that is the first reason, guys, fully managed services. And then built for scale. Because AWS DevOps, you will be using it on existing services like EC2 or Lambda. So when you use on them, they already have a scaling feature within them. So obviously it is built for scale. So you can easily scale it up or down. And then programmable. You can write scripts, you can write shell scripts, you can create a program which you can implement inside AWS developer tools, which can actually impact your DevOps lifecycle. And then automation. So DevOps is mainly automation. So automation is one of the main reasons, and automation is available in everything like Azure DevOps, AWS DevOps, even in GCP. If you are implementing DevOps, automation will be available over there. Or if you manually use DevOps tools to create a DevOps lifecycle, even then automation is required. So DevOps main motive is automation. And then secure. Yes, AWS provides security and it is their first priority. And then pay as you go. Pay as you go model is that whatever you use, you only pay for that, nothing else. For example, you will launch a virtual machine using code deploy. So that virtual machine is running for 2 hours and then it gets terminated. So you'll have to only pay for that 2 hours time. You don't have to pay for creating a virtual machine and running it. You don't have to pay a month's fee. You just have to pay the money for that particular 2 hours. So moving on. Now we've discussed what are the benefits of having DevOps on AWS. Now we'll see what are the tools provided by AWS. So these are the 4 tools provided by AWS, guys, and these are the most basic tools. There are still more tools for developing, but these are the 4 most basic tools for creating a DevOps lifecycle. So the first one is code commit, and then code build, and then code deploy and code pipeline. So let us discuss them. Let's discuss these developer tools in detail now. So first let us discuss code commit. So the name suggests that code commit is a version control tool. It is like GitHub. So it is like Bitbucket. It is a version control tool, guys, but it is provided by AWS, and it also provides the same features GitHub provides or Bitbucket provides. You can do all of those stuff which is available over there, like committing, pull requests, merging branches. You can do all of it even using code commit. You can also see over here code commit allows 5 active users per month. So basically this is going to be your private repository. So it allows 5 users per month. For if you have a startup and you only have 5 members, you can actually use code commit and you won't be charged even a single rupee. And also you will be given 50 GB of space every month. So for example, our repositories maybe maximum of a size of 1 MB or 2 MB, but 50 GB, they provide 50 GB of space for the repository, guys. And also 10,000 Git requests per month, like pull or push requests. So this is code commit. It is a tool. It is like GitHub. It is like Bitbucket. It is the same kind of tool, but it is provided by AWS. And then AWS code build. So the name suggests that this tool is for building your application. So it provides a fully managed CI service, that is continuous integration service. It will compile your source code. You can run tests, you can run unit tests, and also provide software packages and store it in AWS S3 so that you can take out those packages and use it to deploy your application. So you can see here AWS code build, 100 build minutes. That is, if you run a build, it might run for 20 seconds. So like that, you can run any number of builds which come up to 100 build minutes. And also it runs using build.general 1.small compute type usage. So it runs with this, and for every month you get 100 build minutes free. Moving on, AWS code deploy. This is one of the important service, guys. This service is used to deploy your application on any service you choose, like EC2 or Lambda. So It is an automated deployment tool which can deploy services like EC2, Lambda, Beanstalk. So even if you launch Beanstalk, it will be launched in an EC2 instance or Fargate, and also your on-premise setup. So these are the 4 benefits provided by AWS Code Deploy. So first is automated deployments, and then minimized downtime, centralized control, and easy to adopt. So the first one is automated deployments. Is when you set it up, whenever there is a change in your repository, it automatically runs again, it builds your code again, and it gives it back. So that's what automated deployment means. It doesn't build and it stores, it actually deploys it again. Whenever there is a change in your code, it deploys and the change will be visible in your website. And then minimize downtime. So whenever the code is changed, it takes very less seconds. Your website will be down for maybe 1 to 2 seconds and the change will be on your website, guys. So it minimizes the downtime. For example, when you do it manually, you will have to go to your system or your server where your website is launched and you will have to change your code over there. When you do that, the downtime increases, but using code deploy you can minimize that. So I'll show that in the demo, guys. And then centralized control, you can just use your command line interface of AWS or the management console and you can control all of the operations happening in code deploy, code commit, and code build. And then easy to adopt, you can see works with any application, and same experience whether you are deploying it on EC2, AWS or Lambda. That means if whatever service you are deploying it to, maybe EC2 or Lambda or Fargate or Elastic Beanstalk, it provides you the same UI with the same experience. So it doesn't change, it is the same thing, but the deployment environment is different. So this is code deploy, guys. And then finally, AWS Code Pipeline. So we are going to use Code Pipeline. We can use Code Pipeline to create a CI/CD pipeline, guys. We can use all those services to do that. So first thing, it is a continuous delivery tool. That's why it is called a CI/CD pipeline. So it is also fully managed by AWS. As I told you, that is one of the benefit. And also you can automate your website or you can automate your application, which is running on code deploy. So when you create a pipeline, whenever there's a change in code, it automatically pushes it to code deploy and the change will be made. So that's how you use code pipeline, guys. You can see over here, take it as an example pipeline. You have some website over in your source, that is your GitHub. So you build it and you test it using some programs. So after testing it, you can give any number of stages. This is staging. This means you will be seeing this deployed, but you will be seeing it in a IP address which only you might see. You might have given the security group like that. But in production, when it gets deployed in production, then you can view your website using the IP address or the DNS name from any other computer, guys. So this is how you use AWS Code Pipeline. And then, so you can see over here, easy to integrate AWS Code Pipeline with GitHub or with your own custom plugin. So you can integrate GitHub and Code Pipeline easily. You can just click on connect to GitHub. There is an option for that. Or you can use your own custom plugin, like you would have created something in Bitbucket or any other version control tool. You can even use that. And then also it is pay for what you use. It's the same thing, guys. And also there is no upfront costs or long-term commitments. So it is basically free. Whatever services you launch using it, for example, the EC2 instance, so those are charged, not these services like pipeline or code deploy. And also rapid delivery, which basically means whenever there is a change in your code and it is applied to the master branch, it will be applied to your website directly. And then configurable workflow. The workflow, you will have an UI. You can configure your workflow, how it should happen, which is the deployment server, which is the production server, which is the QA server, or you can mention builds or you can skip builds. So you can create a workflow for your own advantage. And then get started fast. This basically means it's pretty easy. They have a lot of documentation, guys. You can just go on, create your own pipeline in no other than like half an hour. So it takes only that much time. And then it is easy to integrate. You can integrate AWS Code Pipeline with any service. You can integrate with even Jenkins. So this is what they say, easy to integrate. So right now let us move on and let us create a CD pipeline using CodePipeline and code deploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html, destination is this. So this is where Apache 2 installs its index.html file, but we'll be deleting that file and launching our hello world application. So you can see here, before install, script/install dependencies and script/server, start server. So I'll show that what actually is there. I'm going to scripts, install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes, and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. And then it will remove the index.html file in. So it will remove the index.html file in this location that will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2, but I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Abspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is, we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open. So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application. But right now I'm launching my website, so I'm going to use only code deploy and code pipeline, guys. So first thing we'll have to do is, we'll have to create a code deploy application. So let me click on application. So I already have one. So this is what I tried. So create application. The first thing it asks is your application name. So I'm going to provide it as web server and Apache 2. So web server Apache 2, this is going to be my application name, and here compute platform. This is the most important thing, guys, because here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there, because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is, it directs or it targets to which instance should this particular code deploy application should deploy the application to, that is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that, and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use a Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Machine Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance, t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance, you can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys, this is the most important thing. You will have to include a IAM role. So why an IAM role? Because the code deploy agent should access your EC2 instance, and also the EC2 instance should be connected to your code deploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 code deploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions, and here you will have to provide code deploy. So you can see Amazon EC2 role for code deploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for code deploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my code deploy. After installing that, I'm just modifying my permissions, and after that I'm installing code deploy, which got downloaded. After it gets downloaded, now I'm starting code deploy, guys. After installing code deploy, I'm going to start the code deploy service. Only if it is started, then I can connect my EC2 instance and code deploy. So I'll copy these and enter it in code deploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we've done all of the required things over here, and then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag, then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I am creating this tag? Because I'm going to use this tag so I'll have to enter this tag over here so that this code deploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now, I'm going to allow an HTTP rule, because I need HTTP because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now I'll go back. And now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values. My value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
If I click here for details, you can see over here, and my instance is showing. So this is the instance and it is showing. So that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once. If you're having a lot of instances running, guys, sorry. If you have a lot of instances running, guys, you can provide half at a time. And after, for example, you have 10 instances, first 5 instances will run. After that, the next 5 instances will start. So if you provide one at a time, if you have 10 instances, first the first instance will get the website, and then the next, and then the next. So it will go one by one. After that, if you give all at once, all of the instances which you have provided, which you have mentioned, will get the website at the same time. So right now I have only one instance, so it doesn't matter if I choose any of these. I'm going to go with all at once. And I'm not using any load balancing, so I'm going to cancel that. And I'm creating my deployment group. So you can see additional settings. Actually, I don't have any alarms or triggers. So I'm just going to go with creating my deployment group. So here you can see I have created my deployment group. and also there is an edit option. Sorry guys, so you can edit it or delete it, or you can create a deployment from here. But I'm not going to create a deployment from here guys. I'm going to create a pipeline which will do that for me automatically. So if I create a deployment from here, every time I'll have to come to code deploy and click on create deployment. I'll have to click on that button, which will create a new deployment every time I change my GitHub code or code in any repository guys. So instead of doing that, I can just create a pipeline which will do that automatically for me. So right now we've created an application and it has a deployment group guys. So we are good with that. We've learned how to create a code deploy application and a deployment group, and also how to connect a EC2 instance with code deploy. So you can see it's still initializing because we've run some commands. So those commands will be running inside. Normally it doesn't take this much time. So right now it's running. So that's okay guys. So next, code pipeline. So only using code pipeline, we're going to connect our GitHub and code deploy. So whenever there is a change in GitHub, so it will be available in our instance. So right now I already created a pipeline which succeeded, and right now I'm going to create a new pipeline for my new code deploy application. So first thing, I'll have to provide a name. I'm going to provide web server pipe. So it will create a role. So it needs a role. It needs a service role, and it will create it automatically. We don't need to create it again and again. And then advanced settings, just click on default location and default AWS management key. Basically, default location means the artifacts, that is the data which will be stored while we run this. That data will be stored in this bucket. So the data will be stored in code line US East 1 and this number. So it will be stored in this S3 bucket guys. So that is default location. If you have any other bucket where you want to store your artifacts, you can provide it in custom location. And then next, now you'll have to choose your source provider. My source provider is GitHub. So I'm choosing GitHub. And the first thing it asks is connect to GitHub. So I'll have to click on it. It takes me and it connected with my GitHub account because I have already logged in. And then repository, I'll have to choose the repository which I have to deploy. So my website is in this repository, which is also called website. So I'm just going to click on it. And branch, I have only one branch, that is master. And then next. So I don't need a build guys. Actually, this is a website. There is nothing to be built. It is a HTML page. There is nothing to be built. So I don't need to worry about building. So I'm going to skip build stage. So now you'll have to deploy. You'll have to click on a deploy provider. So you can see over here, there are various deployment options. You can choose Amazon S3 and launch this website as a static website. You can choose Amazon ECS. You can choose Alexa skill sets. You can choose OpsWorks, even Elastic Beanstalk, and then cloud formations also. But right now, as we are doing code deploy and code pipeline, I'm going to choose code deploy because I already have a code deploy application. So I'm clicking on it. You'll have to choose the region where we created. My code deploy is in North Virginia, so I'm good to go. If I click on this, it should show all of the code deploy applications available in the region. You can see over here, web server Apache and a web server Apache 2. So mine is web server Apache 2. I'll have to choose that. And then deployment group. I have only one deployment group. I'm choosing it and moving on. Next. So this is again same thing. Basic stuff. It asks you to review it. You can review it if you want, or you can just move on. So right now, let me see my instance is running. So currently, if I see, so there is nothing available, guys. So let me run this pipeline. So let me create this pipeline. So if I create this pipeline, what do you expect will be available? So there will be an UI with two things, that is the source stage and the deploy stage. So congratulations, the pipeline web server pipe has been created. So you can see source. My source is GitHub and it is in progress. Once it gets succeeded, then it will move on to deploy stage. And you can see over here, you can edit this. You can add more stages, that is more source over here. You can add more deployment stages over here, but I'm not going to do anything. I'm just going to, because I have already created. So right now GitHub has been succeeded. My code has been properly taken. So it took merge branch master from this particular GitHub repository. So right now code deploy is running, guys. So I'll go to details. Let us check whether this succeeds or not. Only if this gets succeeded, then my website will be available. So you can see, oh, my code deploy got succeeded. So right now if I go here, you can see all the events happened and also whether it is succeeded or not. If any of this was not succeeded, for example, if this gets failed, so you will see the error code over here, and if you click on that error code, it will take you to a log page which will show what error is available in your code. So you can use that to debug your application. So you can see over here, succeeded, before install succeeded. So before install took 13 seconds. Why? Because in my app-spec YAML file, you can see before install will install dependencies, and also it will start the server. So as it already showed you in my scripts, so install dependencies will update my application once again, my instance once again. It will install Apache 2. It will also remove the HTML page, index.html page within this location, because I want to launch my application, guys. So then start server will start my Apache 2 service. So only if the Apache 2 service is started, then I'll be able to see my website. So right now, as my pipeline is succeeded, I should see my website, guys. If I go over here, if I choose my IP or my DNS name, if I go over here and hit. So right now you can see hello world to Intellipaat. This is the website which is currently running, guys. So I'll go and show over here index.html, and you can see hello world to Intellipaat. So right now, as I told you, this pipeline should automatically execute whenever there is a change in the master branch. So because that is what we mentioned, whenever there is a change in the master branch in this repository, this pipeline should automatically run. So what I'm going to do is I'm going to change few values over here. So I'm going to just change to hello world, and then I'm going to commit my changes to master branch. So once I commit my changes, if I go over here, it should automatically start. So it is currently in progress because I have changed my code. After some time, you can see there will be a commit ID. The commit, which commit it took, will be present over here. Once it succeeds, that change will be implemented in my code deploy agent. That is my EC2 instance automatically, guys. You can see source update index.html because this is my latest commit. This is the latest commit ID which it took. So you can see it's running, guys. So right now, hello world to Intellipaat. So now it changed to hello world. So this gets succeeded and this changed to hello world, and you saw there was no downtime over here. So this is why you use a DevOps pipeline. This is how you create a pipeline using code deploy and your version control tool. So whenever there is a change happening in your version control tool, whenever there is a change happening here, so I'll just, okay. So whenever there is a change happening in your version control tool, that is this change when it is committed in the master branch, once it is committed in the master branch, this pipeline will automatically detect the change happened in your GitHub. It will take the latest commit made and it will run it once again. Once it succeeded, once it is properly run, then it provides the code to code deploy. So code deploy right now will download the contents of this particular GitHub repository. It will store in some location. We do not know where exactly it stores it. It stores it in some location. It will copy the index.html file into /var/www/html. So only if the index.html is available in that particular location, it will be taken by Apache 2 server, guys. So you can see this is how you create a code pipeline and using code deploy and GitHub. So we've learned how to do this.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Let us create a CD pipeline using code pipeline and code deploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html, destination is this. So this is where Apache 2 installs its index.html file, but we'll be deleting that file and launching our hello world application. So you can see here, before install, script/install dependencies and script/server, start server. So I'll show that what actually is there. I'm going to scripts, install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes, and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. And then it will remove the index.html file in. So it will remove the index.html file in this location. That will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2. But I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Abspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is, we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open. So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application. But right now I'm launching my website, so I'm going to use only code deploy and code pipeline, guys. So first thing we'll have to do is, we'll have to create a code deploy application. So let me click on application. So I already have one. So this is what I tried. So create application. The first thing it asks is your application name. So I'm going to provide it as web server and Apache 2. So web server Apache 2, this is going to be my application name, and here compute platform. This is the most important thing, guys, because here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there, because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group, but to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is it directs or it targets to which instance should this particular code deploy application should deploy the application to. That is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use a Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Mission Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance, t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance, you can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys. This is the most important thing. You will have to include a IAM role. So why an IAM role? Because the code deploy agent should access your EC2 instance, and also the EC2 instance should be connected to your code deploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 code deploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions, and here you will have to provide code deploy. So you can see Amazon EC2 role for code deploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want, you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for code deploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my code deploy. After installing that, I'm just modifying my permissions, and after that I'm installing code deploy, which got downloaded. After it gets downloaded, now I'm starting code deploy, guys. After installing code deploy, I'm going to start the code deploy service. Only if it is started, then I can connect my EC2 instance and code deploy. So I'll copy these and enter it in code deploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we have done all of the required things over here, and then adding storage. 8 GB is more than enough, and then you'll have to add a tag, guys. So to add a tag, hit on add tag. Then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I am creating this tag? Because I'm going to use this tag so I'll have to enter this tag over here so that this code deploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now I'm going to allow an HTTP rule, because I need HTTP because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now I'll go back. And now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values. My value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance. If I click here for details, you can see over here, and my instance is showing. So this is the instance and it is showing. So that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once. If you're having a lot of instances running, guys, sorry. If you have a lot of instances running, guys, you can provide half at a time. And after, for example, you have 10 instances, first 5 instances will run. After that, the next 5 instances will start. So if you provide one at a time, if you have 10 instances, first the first instance will get the website, and then the next, and then the next. So it will go one by one. After that, if you give all at once, all of the instances which you have provided, which you have mentioned, will get the website at the same time. So right now I have only one instance, so it doesn't matter if I choose any of these. I'm going to go with all at once. And I'm not using any load balancing, so I'm going to cancel that. And I'm creating my deployment group. So you can see additional settings. Actually, I don't have any alarms or triggers. So I'm just going to go with creating my deployment group. So here you can see I have created my deployment group, and also there is an edit option. Sorry guys. So you can edit it or delete it, or you can create a deployment from here. But I'm not going to create a deployment from here, guys. I'm going to create a pipeline which will do that for me automatically. So if I create a deployment from here, every time I'll have to come to code deploy and click on create deployment. I'll have to click on that button, which will create a new deployment every time I change my GitHub code or code in any repository, guys. So instead of doing that, I can just create a pipeline which will do that automatically for me. So right now we've created an application and it has a deployment group, guys. So we are good with that. We've learned how to create a code deploy application and a deployment group, and also how to connect a EC2 instance with code deploy. So you can see it's still initializing because we've run some commands. So those commands will be running inside. Normally it doesn't take this much time. So right now it's running. So that's okay, guys. So next, code pipeline. So only using code pipeline, we're going to connect our GitHub and code deploy. So whenever there is a change in GitHub, so it will be available in our instance. So right now I already created a pipeline which succeeded, and right now I'm going to create a new pipeline for my new code deploy application. So first thing, I'll have to provide a name. I'm going to provide web server pipe. So it will create a role. So it needs a role, it needs a service role, and it will create it automatically. We don't need to create it again and again. And then advanced settings, just click on default location and default AWS management key. Basically, default location means the artifacts, that is the data which will be stored while we run this. That data will be stored in this bucket. So the data will be stored in code line US East 1 and this number. So it will be stored in this S3 bucket, guys. So that is default location. If you have any other bucket where you want to store your artifacts, you can provide it in custom location. And then next, now you'll have to choose your source provider. My source provider is GitHub. So I'm choosing GitHub. And the first thing it asks is connect to GitHub. So I'll have to click on it. It takes me and it connected with my GitHub account because I have already logged in. And then repository, I'll have to choose the repository which I have to deploy. So my website is in this repository, which is also called website. So I'm just going to click on it. And branch, I have only one branch, that is master. And then next. So I don't need a build, guys. Actually, this is a website. There is nothing to be built. It is a HTML page. There is nothing to be built. So I don't need to worry about building. So I'm going to skip build stage. So now you'll have to deploy. You'll have to click on a deploy provider. So you can see over here, there are various deployment options. You can choose Amazon S3 and launch this website as a static website. You can choose Amazon ECS. You can choose Alexa skill sets. You can choose OpsWorks, even Elastic Beanstalk, and then cloud formations also. But right now, as we are doing code deploy and code pipeline, I'm going to choose code deploy because I already have a code deploy application. So I'm clicking on it. You'll have to choose the region where we created. My code deploy is in North Virginia, so I'm good to go. If I click on this, it should show all of the code deploy applications available in the region. You can see over here, web server Apache and a web server Apache 2. So mine is web server Apache 2. I'll have to choose that. And then deployment group, I have only one deployment group. I'm choosing it and moving on. Next. So this is again same thing, basic stuff. It asks you to review it. You can review it if you want, or you can just move on. So right now, let me see my instance is running. So currently, if I see, so there is nothing available, guys. So let me run this pipeline. So let me create this pipeline. So if I create this pipeline, what do you expect will be available? So there will be an UI with two things, that is the source stage and the deploy stage. So congratulations, the pipeline web server pipe has been created. So you can see source. My source is GitHub and it is in progress. Once it gets succeeded, then it will move on to deploy stage. And you can see over here, you can edit this. You can add more stages, that is more source over here. You can add more deployment stages over here, but I'm not going to do anything. I'm just going to because they have already created. So right now GitHub has been succeeded, my code has been properly taken. So it took merge branch master from this particular GitHub repository. So right now code deploy is running, guys. So I'll go to details. Let us check whether this succeeds or not. Only if this gets succeeded, then my website will be available. So you can see, oh, my code deploy got succeeded. So right now if I go here, you can see all the events happened and also whether it is succeeded or not. If any of this was not succeeded, for example, if this gets failed, so you will see the error code over here, and if you click on that error code, it will take you to a log page which will show what error is available in your code. So you can use that to debug your application. So you can see over here, succeeded, before install succeeded. So before install took 13 seconds. Why? Because in my app.spec.yaml file, you can see before install will install dependencies, and also it will start the server. So as it already showed you in my scripts, so install dependencies will update my application once again, my instance once again. It will install Apache 2. It will also remove the HTML page, index.html page within this location, because I want to launch my application, guys. So then start server will start my Apache 2 service. So only if the Apache 2 service is started, then I'll be able to see my website. So right now, as my pipeline is succeeded, I should see my website, guys. If I go over here, if I choose my IP or my DNS name, if I go over here and hit. So right now you can see hello world to Intellipaat. This is the website which is currently running, guys. So I'll go and show over here index.html, and you can see hello world to Intellipaat. So right now, as I told you, this pipeline should automatically execute whenever there is a change in the master branch. So because that is what we mentioned, whenever there is a change in the master branch in this repository, this pipeline should automatically run. So what I'm going to do is I'm going to change few values over here. So I'm going to just change to hello world, and then I'm going to commit my changes to master branch. So once I commit my changes, if I go over here, it should automatically start. So it is currently in progress because I have changed my code. After some time, you can see there will be a commit ID. The commit, which commit it took, will be present over here. Once it succeeds, that change will be implemented in my code deploy agent. That is my EC2 instance automatically, guys. You can see source update index.html because this is my latest commit. This is the latest commit ID which it took. So you can see it's running, guys. So right now, hello world to Intellipaat. So now it changed to hello world. So this gets succeeded and this changed to hello world, and you saw there was no downtime over here. So this is why you use a DevOps pipeline. This is how you create a pipeline using code deploy and your version control tool. So whenever there is a change happening in your version control tool, whenever there is a change happening here, so I'll just, okay. So whenever there is a change happening in your version control tool, that is this change when it is committed in the master branch, once it is committed in the master branch, this pipeline will automatically detect the change happened in your GitHub. It will take the latest commit made and it will run it once again. Once it succeeded, once it is properly run, then it provides the code to code deploy. So code deploy right now will download the contents of this particular GitHub repository. It will store in some location. We do not know where exactly it stores it. It stores it in some location. It will copy the index.html file into /var/www/html. So only if the index.html is available in that particular location, it will be taken by Apache 2 server, guys. So you can see this is how you create a code pipeline and using code deploy and GitHub. So we've learned how to do this.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now what we are going to see is Terraform. So we'll have to understand few things before getting into Terraform. Now, this is my AWS account. Now this is my AWS account. For example, in this case, this guy is a system administrator. And this guy is a system administrator. Okay, who's handling this environment? Who's handling this environment? AWS Cloud. Now what happens? He is the one who set up all infrastructures in our cloud environment. All infrastructures in our cloud environment. Like it can be, he is the one who architected the design, and that a cloud application, cloud environment consists of EC2, VPC, and other services like S3, database, RDS, etc. etc. Now here, in this case, let's consider he is working for 4 years in a company. He worked for a company. He worked for 4 years in a company. Then, if he moves out of the company or the organization, if all of these environments, whatever he has set it up, if it doesn't have any proper, if it doesn't have any proper documentation, what will happen? A new guy who is coming, whoever is coming, will not understand what exactly it is, like how the infrastructure is being created, what is the purpose of what is the purpose of EC2 service, how many EC2 services are there, and everything will be in a mess. Basically, but the new guy will not understand how exactly the entire architecture is being designed or created. And the next thing, everything is a manual task. Everything is a manual task in the sense, here if I wanted to create 5 EC2 instances, I will have to create it 5 EC2 instances manually. The same way, if I wanted to create a VPC, I will have to create it manually. And everything is a manual process in creating all of these services using a console. So now whatever we are doing it here is all through console. So whatever I'm creating it here is all through console. Again, if I wanted to create an EC2 instances, what I will have to do? Again, I'll have to go launch an EC2 instance, and again I'll have to create it. Correct? In this case, a new tool called as Terraform comes into picture. It is not a very old tool at all. It was developed in the year 2014, if I'm not wrong. It was developed in the year 2014. Okay. Now, what this tool does it came up with a new concept called as infrastructure as code. Now, what we do, instead of creating it manually over console, so what we do is we create it as a code and we deploy it. Now what happens, anything which you created will have a trace of the code, correct? Like whatever, if I've created 3 EC2 instances, and I'll have a code of it, like, so that, and moreover what happens is it brings reusability. Like I explain you all those things, it brings in reusability. So all you do is you write code once and you use it multiple times. And moreover, it brings in automation of infrastructure. And how this code is being created? So they call it as HCL language. So whatever the code which we write to create this environment is called as HCL. It's called as HCL language. And how do we do it? How do we create it? And we will see everything step by step. Use of Terraform. Terraform is to code your infrastructure. that is as simple as that. Like instead of creating everything over console manually, so what we do is we create everything using code. And what is that code? And that code is nothing but HCL. An extension of Terraform file is called as .tf files. .tf. Like for Ansible, we save it as .yml file, right? Likewise, any Terraform script will be saved in the form of .tf files. Now, using Terraform, what are all the services we can code? There are lots and lots of services which can be coded using Terraform, like major cloud platforms like AWS, Google Cloud, Azure, IBM, and then other providers, like for example, if you wanted to manage any other softwares. In nutshell, I can show you the list of providers which Terraform supports. Terraform providers. Now, using Terraform, what all we can create it? These many services we can code it. So if I wanted to create, for example, if I wanted to create what are we have seen here? Let's consider if I wanted to create an SQL server. Using Terraform, we can create it. For example, if I wanted to create a chef cookbooks, I can use Terraform to create it. If I wanted to create Azure Active Directory, Terraform supports. If I wanted to maintain the entire AWS cloud or Azure cloud or Google cloud, everything is done using Terraform. GitLab. So whatever we have seen here. For example, let's consider a use case where I wanted to create a user in GitHub. Now what we do, we manually log into GitHub and then we create user and then we whatever the permission which we wanted to assign it to the user, we will be able to do it. Now using Terraform, we can do the similar setup also. See here, if I wanted to create any GitHub repository, I can create it. How we will create it, let's see. But whatever the manual task which we do using a console, which can be achieved using Terraform as well. And the main purpose of it is to code your infrastructure. How does it benefit? It benefits in such a way that we can keep track of every resource which we configure using Terraform, and also if we wanted to reuse the code. For example, I write the code once like function, and then it can be used later everywhere wherever we wanted to. Now we need to understand few terms before we get into creating any services using Terraform. Those are here. The first one is resource. Resource is nothing but, for example, if I wanted to create an EC2 instance, let's consider I wanted to create an EC2 instance. Now, what we define? No, before resource, let me put few other things also. Providers. So providers are nothing but which one we are going to use it. For example, it can be AWS, or it can be GCP, or it can be Azure, or it can be Redis, whatever it is. So what we are going to code using Terraform. So which one it is, and the basic structure remains same, but the functionality wise it differs from providers to providers. For example, in AWS we call it as EC2 service. In GCP it is called as VM. correct? Those terminology differs, but the core concept remains same. And the next one is resource. What is resource? Let's consider we are using AWS provider. We are using AWS provider. Inside AWS provider, I wanted to create an EC2 instance. EC2 instance. In this case, what we do, we create a resource. This is called as resource. Any services inside your provider is called as resource. Whatever we are trying to create is then it's called as resource. Variables. So variables are nothing but an input value which can be defined while writing our Terraform script. Output. Now, output is the resultant value. For example, using a provider AWS, I'm creating an EC2 instance. Okay, let's consider an input value I'm giving. So, if I wanted to create an EC2 instance, what all is required? If I wanted to create an EC2 instance, now what we can do is we can input these values while creating our EC2 instance. That is nothing but variable. And the next one is, for example, after creating this EC2 instance, it will come up with some values. For example, instance ID, correct? Automatically it comes up with. Then instance IP address. And these are the output values. So whatever the input values which we are giving it, from that we will get an output value. So that is called as output. Okay. Terraform plan. This Terraform plan is a command. Okay. Terraform plan is a command. In the sense, for example, I have created all of these code using all of these all of these things. I've created a Terraform script. Now I wanted to test that script before I actually apply it. In that case, what we will do, we will run Terraform plan. So Terraform plan, what will happen is it will just do a dry run before we apply it. That is what Terraform plan. Terraform apply. So Terraform apply is a command which is used to apply all your changes. In the sense, if I wanted to create any EC2 instances, first what will I do? I create the Terraform script. Then to test it, I will run Terraform plan. Then if everything looks good, then what we will do? We will we will then run Terraform apply. Then Terraform apply will apply all your changes in the script. Then Terraform destroy. So destroy will delete all your changes, whatever is there in your, delete all your changes. And the next one is Terraform init. Here, let's consider we are using AWS provider, correct? Now here, let's consider this is your machine from where we are running all of these scripts. Now here, all we would have done is install Terraform into this machine. Now I wanted commands which is specifically for AWS. Correct? Only then AWS related configurations will work. In that case, after writing all your code, first you will have to run Terraform init. So what it does is it initializes all modules or all the required modules which are essential to run your script. That is nothing but Terraform init. which initializes all your modules which are required to run your service. I mean, run your scripts. That is nothing but Terraform init. Then what else is required? Very important thing is TF state file. TF state file. Name itself says, in the sense, TF state file is nothing but a state file which holds all configurations of whatever you have created using using Terraform. In the sense, for example, I wrote a script where it creates one EC2 instance. Okay. Now, in the same EC2 instance, I mean the same script, what I'm doing it is I'm creating one more EC2 instance. Now, first one EC2 instance configuration is already added. One configuration is already added. It's already there. Correct. Now I'm adding second one. In this case, what it should do, it should not create the instance which has been already created. All it has to do is it has to create only the second one. How Terraform will know that one instance is already being created and only the second one has to be created? And in that case, Terraform state file comes into picture. So any configuration which you run, it first checks with your TF state file whether all of these configurations are matching your TF state file and with the current configuration file which you have written. If anything is missed, then it will create the required services. So that is the function of TF state file. Cool. Now, and this is one of the most predominantly or widely used tool in DevOps industry at this point of time. Till now, if like any infrastructure related activities are handled manually, now everything is being coded, and Terraform is one of the important tool which is being used in the industry, and I would really recommend you guys to go through it. So we'll use AWS for our configuration. What is the first step? First step is to install Terraform on your machine. Now what I will do, I will use one of my EC2 instance which I've created. Okay, first what we'll do, let's install Terraform on that machine. So how do we do it? All you'll have to do is download Terraform. You will get the version of it. So all you can do is whichever version you wanted to install. If you're trying it in your local machine, you can use you can download Windows and then try it. Or if you have any Windows machine, just download accordingly. Let me download this one here. Copy and then wget. Yes. Now I've downloaded the file, and then you will see something called as this. Then what you need to do is you will have to move this file to, if it is Linux machine, move Terraform to user local bin. Then what you will have to do, check then cd space user local bin. Then once it is done, Terraform Why it is not running? Terraform to user thing. Okay, so you will have to move, just download the file, just copying it. I'm just writing it here so that then move the file to move, unzip, first unzip, second move the file to move Terraform to user bin. Once it is done, you will be able to you can check and verify with the command terraform - and the latest version is this one. 12.24 is the latest version which is available. Now we are set with this. Now what is the next step? Let's consider we wanted to create an EC2 instance from this machine. In this case, what we will have to do is, now one logical question, okay? If I wanted to manage this account, what is required? For example, if I wanted to manage this AWS account using an CLI, what is required?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay guys, a quick info, if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Here, so what we need to do is, we need a credential where we can manage the account using our Terraform or whatever it is. For that, what we will have to do, first we will have to go and create one user. If somebody is new to the cloud, so what you'll have to do is go to service, IAM is a service which is used to create your user accounts. Then go to users. Then I'm creating a user with the name Terraform. So all it needs is just programmatic access. So I'm just giving programmatic access and then click next. Here, what we'll do, we'll attach existing policies directly. We'll give administrator access so that using the Terraform account, it can do anything it wants over this account. But in real time, you will have to come up with a best practice solution where we can actually give access to the console in a better way for any programmatic access. Now let me name Terraform, just Terraform, and then click review, create user, and then let me download this credentials and I'll click the close it. Now here what we are trying to do, so we are trying to create an EC2 instance using this Terraform. So what I'm doing it is, I'm just going to one directory, and then what I'm doing, I'm creating one directory, mkdir, and then just Terraform. And then I'm going into that. I'm creating one more directory, mkdir. I'm creating DevOps. So in this directory only, we will have all our configurations will be in this directory. Correct? Here, what we'll have to create, we will have to create one file called as main.tf. let me create one file here. In this, let me get into this file, insert. Now, what is the first step? If we wanted to manage, we will have to define provider and mandatory. So now, first what we will do, we will define our provider here. We will define our provider here. Version is nothing but, earlier they were using 2.2 version 2. With 3 they have included so many other new services also, like ECS cluster, so many other services we also included in version 3 with new features. That's it. Now what I'm doing it, I'm just doing this one. That's it. Greater than or equal to 3 and provider AWS version region. Now it is done. Now what we will have to do, we will have to download that provider into our machine. How do we do it? Which command we use that to initialize all modules? Terraform init. So okay, now we know that we wanted to configure AWS account. Now how AWS, I mean, how this Terraform will know that which AWS account I will have to manage? It will not know, correct? In that case, what we will have to do, we will have to configure credentials of that AWS account with this Terraform. How do we do that? In .df. So what are the keys which we have created? Just give me a moment. Access key ID. What was that? Now here we will have to give our credentials, whatever we have created. Access key ID, shift insert, pass your access key ID and then pass your that's it. Good. This is our configuration now. This is our configuration. Now let's create an EC2 instance. Let's create an EC2 instance. Now our Terraform is ready to configure our AWS account. Okay. Now here what we will do, we'll create an EC2 instance using Terraform. So how do we do it? You can either use main.tf, or if you really wanted, no, you can create multiple files also. At this point of time, let's not do that. What we'll do, we'll continue editing our file. If I wanted to create any resource, then what I should use? I should use a resource, correct? I should use a resource. Now let's go and get the what we are trying to configure. We are trying to configure EC2. I'm trying to make it simple so that you understand it. That's it. So this one we have seen, right? Access key and secret key. Now, access key and secret key is unique to each and every account. For example, I have an AWS account. You also have an AWS account, and others will also have their own AWS account. Now, using Terraform, how will I define which AWS account I will manage it? And that is where a access key secret key comes in. Okay. Now let's see. Now what it does. AMI is nothing but, like, for example, AMI is nothing but like when we launch an EC2 instance, what we do. Like, see, whatever we are doing it here, we are doing it there manually. Whatever we are doing it here manually, we are doing it there also. We select an AMI, right? So instead of just selecting over console, so what we do is we give an AMI ID. Every image as an ID. Every image as an ID, and that is what we are giving it here. Okay. Now, what are all the features it supports? Let's consider if I wanted to create an EC2 instance. These are the arguments which you can pass it. In the sense, which availability zone you wanted to pass, like US East 1A or US East 1B, everything. Now, at this point of time, what else is required? As mandatory, what else is required? We need key, correct? We will create key name. So these are the arguments which are being passed to the script so that we can create an EC2 instance. Now let's consider key -name, which is nothing but I have one key which is DevOps, and tag is nothing but the name which we generally we give while creating an EC2 instance. Now name equal to, let's consider Terraform first instance. Terraform instance. Terraform instance. Now our first script is ready. Now what are we are doing? See, this AWS underscore instance is the keyword. Which resource is what which we are creating? Which resource which we are creating here? We are creating AWS instance. This is the name of the resource which we are giving it. Okay, and for this AWS instance to launch an EC2 instance, what all is required? We can pass. See, anything which is given required is mandatory. There is arguments AMI and instance type is mandatory. To launch an EC2 instance, these two parameters are mandatory. Other than that, we can customize all other configurations. All other configurations we can customize it. Now, till here we are done. Resource AWS instance, Terraform, AMI we have given, instance type we have given, key name we have given, and then we have given a name for this EC2 instance. Okay. Now, what is the next step? We will have to Terraform plan. Correct. So why do we do Terraform plan? So we run Terraform plan to check whether all our configurations are done properly or not. Let's do it here. Now here, see, it is asking in which region we will have to configure it. You remember? So while configuring providers, there was one option here, region, correct? Which I have deleted it. Region. Now here you can define your default region. US East -1 is Virginia. I have defined it here. Now if I run Terraform plan, US East 1. Wait, it is showing error. Because key underscore name. Now what will I do? Terraform. Now what it says? It says new mission will be launched. So this will be the configuration. Now what will I do? So how will I create a new machine here? I mean, if I want to apply these changes, what will I have to do? Terraform, apply. Which command? Apply. Terraform apply. Now you will have to give yes. The moment you give yes, it says error. No subnets found for the default VPC. Please specify the subnet. Now what happens is, since whatever we have given it here, it tries to launch it on the default subnet. Now what I've deleted my default subnet. I've deleted, when you look at here VPC. See here, I've deleted the default subnet and I've created my own subnet. With that configuration, what it does is, so whatever we have done here, it tries to create this EC2 instance in the default subnet. Now that is what we got an error. See, for launching source instance, missing no subnets for the default VPC. Please specify the subnet. Now what we will do? We will go configure main.tf, then include one more configuration, which is nothing but subnet. Let's check whether it is right. Subnet underscore ID. That is the argument which we will have to pass. And this is the subnet ID. Now again, what we will have to do after making changes, Terraform plan. Okay, now if you look at here, it will say that subnet ID is this one. Correct? Earlier, when you look at, you would have not seen that. Now Terraform apply. Cool. Now we can see that one resource is added. Let me go to my EC2 instance. Earlier it was one instance running. Now it is two instances. Second instance, this instance is running here, and whatever configuration which we have given, it has come up. Now you can see one thing here. It did not have any public IP address. Correct? It did not have any public IP address. Now in this case, what we can do, what is required, if I wanted to connect to this machine, a public IP address is required. Correct? Now let's create a public IP address for this machine and then attach it to it. Now in this case, Terraform apply is already done. Earlier you will not see one file called as terraform.tf state. After you apply your first change, this file will get created, terraform.state file. What is the purpose of this terraform.state file? It maintains all your information about your configuration. This is your instance ID. See, this is your instance ID. The statefile maintains all information about the resources which are configured using Terraform. Now let's see. Now what is the second requirement? If we wanted to attach any public IP address to that machine. If you wanted to attach any public IP address of this machine. Okay. Now in this case, what we wanted to do, any cases, if I wanted to create a public IP, there is a resource called as AWS EIP. Correct? There is a resource called as AWS EIP. Just go there. Here, what will I do? Create and so this. Now what we are doing here, we are creating one more resource, which is nothing but AWS EIP, and let's name it as Terraform instance EIP. Now this is nothing but getting a value of this is how we get value of other machine. So whatever we got it here, see the whatever we are getting it here, the what is this syntax is the older version syntax. Here we don't need that. This all of these things are not required. Now what I need, to which machine we are attaching this elastic IP? To this machine, correct? And what is the resource name? Which is AWS underscore instance. And what is the name of the resource? Which is Terraform. It is Terraform. And ID, to understand that, we will have to understand a bit about what are all the values it results. Let's consider, where is the EC2 instance? AWS instance. See, attribute reference is nothing but what are all the values it can result. In the sense, see, what are all the values you get it in your TF state file. Terraform.tf state file. Here, what is that? ID, correct? See, this value it results from this configuration. What is that configuration? This value holds this machine. Now what we are doing it in this configuration, I'm creating one more service which is nothing but EIP, and this will after creating that elastic IP, it has to be attached to this EC2 machine. How do I know that to which EC2 machine I will have to attach? Using this configuration value, AWS instance.terraform.id. This ID actually holds what? The value of that machine, which is nothing but this one. This one, the value this one, let's consider if I run this value, what will happen? Terraform plan. See what happens. It creates an EAP and then attaches and gets attached to that EC2 instance. Same way, what will happen? Let's see if I give that value. I'm replacing it with, so these are dynamic values which we can get it. How do we get it? AWS underscore instance underscore dot terraform dot id. Now again, if I run terraform plan, See, we got the same value. Now let me apply it. Terraform apply. Ask for check, select yes. Now you don't see that public IP, any public IP is being attached here. Now if I refresh it here, see, one IP got attached to it. And this is how it works. Now, using the same concept, what we can do is we can create any number of services which AWS provides with bit of fine tuning that is required. That is required according to a configuration, the best practices which we follow and everything. Now, let's talk about something called as variables. Now, the same concept is same. Variable is nothing but if you wanted to input any variable, then we use concept called as variable. Correct? If you wanted to pass any values from the user or get values from the user, then we define variable. And how do we do it? There are multiple ways to do it. One, what you can do is you can create a file called as variables.tf, whatever it can be. I'll give it as inputs.tf. Inputs.tf. You can create the same method also. I created with the name inputs.tf. So what we can do is let me get some values from the user. Why do we have to give this value automatically here? If I give, everybody can use it, right? So what we can do is we can define it as a variable so that it doesn't being exposed. Now what I will do, I will define it in such a way that give var dot access underscore key and then var dot secret underscore key. So in this case, after defining it here, so go to inputs.tf file. We will have to define that variable. So how do I define that variable? Key name is variable and give the name variable. Let's, what is the name I'm giving? Access underscore key. Then open bracket and then go close bracket and then name is, we will have to define which variable type it is. Now what variable type it is? That is string. And there are different types of variables also, like list of string, maps of string, tuple of string, lots of other things are also there. At this point of time, let's not get into that level. So the value which we require there is string. And how do we do it? Type equal to string. That's it. The same way, we have one more variable also, secret underscore key, type equal to string, and then close it. Now with this, what happens? Now let me check the configuration, whatever I have done, Terraform plan. See, now here it asks for the value. What is the value? var.access key, which I will have to give it from. And then secret value. That's it.
So what I'll be doing is, first of all, let me go ahead and show you how a network like this is possible, where you do not have internet connection in one part of the network and you have internet connection in the other part of the network. Okay. So first of all, you'll have to sign up on AWS. Okay, so let me just quickly log in. And when you have signed up on the cloud, this is how your dashboard is going to look like. This is how your dashboard is going to look like. These are all the different kind of services that AWS offers, and we are going to make use of some today to do what we have to do. All right, great. So now that we are on this management console, the next thing that I'm going to do is I'm going to choose a service. So when you want to deploy any kind of server, if you want a machine from AWS, the kind of service that you have to make use of is called Elastic Cloud Compute, right? So the short form of this is EC2. So you will have to make use of a service called EC2. So EC2, you can choose, you can go to all services under compute, you will find the EC2 service, just click over there. And this is the management console that you will get. Okay. Now my job is to deploy a server. I will do that. But first I need the network that we were talking about, since the past 15-20 minutes. We need the network ready first where we will be deploying our servers. Okay. So the EC2 service is for deploying your servers. Now for getting your network or deploying a network on cloud, there's again a service, and that service is called VPC, which is called Virtual Private Cloud. So we are going to type in VPC, and you will get isolated cloud resources kind of a service over here. Just click over it. And here you can deploy the kind of network that you want. Okay. So now let me, brief you about what we are going to do. So first of all, whenever you talk about networks, guys, networks, the word network can be a very big architecture, but networks have subparts to it as well, which are basically called subnets. So if I have let's say your office network, so you guys must be working in offices, you might be in colleges. So your office will have one network. Then in that one network, you will have, let's say, a network for the HR department. You will have a network separate for the developer department. Then you will have a separate network for, let's say, your leadership team. So everyone will have different access to the different part of the network, and every network will have its own access. Okay. So first of all, let's deploy the big network. Let's deploy a network for our whole application, right? And our whole application, I'm not restricting it to say that this whole network will have internet access or not. This is the overall network that we are deploying right now. And inside this network, then we are going to create subparts where we are going to define the functions that each subpart can have. For example, some parts will have internet access, some parts will not have internet access. So that is something that we are going to do now. Okay. So first, let's go ahead and create a network. For example, let's create a network for your office. So let's call this network as Netflix. Okay. This is where all my resources are going to be. So I'm going to name it as Netflix, and let me give, an address. So everything that you deploy on a network has, an IP address. For example, right now, if you're accessing the internet, your computer has an IP address. Why? Because you are connected to a network which is called internet. Similarly, if you are connected to your office network, you also need to have a separate IP address which will make you recognize on that network. Okay. So now what we're going to specify in this IPv4 CIDR block is the range of IP addresses that I'm going to have. That is
let's say if your computer connects to my network, what is the kind of IP address which will be assigned to you? So let's say I specify over here that anyone who's trying to connect to this network will have an IP address which will look something like, let's say this. So this is the range that I'm specifying over here. So here in this range, so your IP address will always begin with 10.1, and then this number will change according to what your network configuration is. So this is the range that I'm specifying over here, and this range is where my application is going to be deployed in. Okay, so let's click on create, and what you have now done is you have created an office network, or you've created a network for your application. Okay, now inside this network I'm going to create subparts. Okay, because some resources I want to give internet access and some resources I do not want to give internet access. So let's see how we can go ahead and specify that. Okay, so I have created a network called Netflix. Now inside this network, let's create some subparts. So for creating the subparts to a network, what you do is you create subnets. Okay, so I'm going to click on subnets. So let's create some subnets for my Netflix network. So I'll click on create subnet. Let's say what I'm creating right now is for a network which is going to have internet access. So let's call all the networks which will have internet access as public, and all the networks which will not have internet access as private. Okay, so let's call this network as public. And when you're deploying servers in AWS, you can deploy it in many data centers. Okay, so right now what we are dealing with is the Oregon region. So Oregon is basically a place in the US where AWS has many data centers. And how many data centers are there? There are almost 4 data centers that you can choose from. So let's create a public subnet in 2A data center. Okay, and let's call this public subnet as 2A. And this subnet will be deployed obviously inside my main network, which is Netflix. So let me select that, right? And it is going to be deployed in the 2A data center. And let me specify the IP address range, which is going to lie obviously between this particular IP range that I specified earlier. This will be the IP range where I will have, my resources will be assigned the IP address from. Okay, so let me specify it as 10.1.1.0/24. So these numbers that you see /16, they basically denote a range. 20, if I specify something called as /24, that's a smaller part of a range which is /16, right? For example, if I specify, so just assume it like this, if I specify /16, there are going to be around 65,000 IP addresses that I can give using this range. Okay, now when I specify something as small as /24, I will have an IP range of around 256 to 256 servers. So I've just created public 2A, which is basically a part of my Netflix network, and it is deployed in the 2A data center, right? Similarly, let me create one more subnetwork. Let me call it as public 2B. This is going to be a part of the 2B data center. It is going to also have internet access. It is going to be a part of my Netflix. What do you say? It will going to be a part of the Netflix network, right? And the range is going to be 10.1.2.0/24. Okay, let's go ahead and create it. Okay, so now what we have done is we have created 2 subparts in the data center 2A and in the data center 2B. Now let's go ahead and create private subnets which are not going to have internet access. So let's create them. So let's call this as private 2A. It's going to be part of my Netflix main network. It's going to be a part of the 2A availability zone. And this is going to basically have this IP range. Okay. Now, similarly, let me create a private 2B as well. /24, and let me go ahead and create it. Okay. So, okay, there's a small change over here that I'll have to do. So once you have deployed it, guys, you can verify if it has been deployed in the correct data center or not. For example, private 2A has been deployed in 2A data center. That is great. But when we talk about public 2B, it has again been deployed in 2A data center itself. So what I can do is I can delete it quickly and I can create public 2B once more. Okay, so let me create public 2B, and VPC is going to be my Netflix network. It's going to be part of my 2B network, and this is going to be 10.1.2.0/24. Okay, so now I have private 2A, I have private 2B, I have public 2A, I have public 2B deployed, and these should be now in the respective data centers. If I've named it 2A, it's in 2A. If I've named it 2B, it's in 2B. If it's in 2B, it's in 2B, and 2A is also there in the 2A data center. Great. So I have my network deployed. Now let me go ahead and define their functions. So what I've decided is my public subnets will have internet access and the private will not have internet access. Okay. So what I'm going to do is first I need internet connection to my network. So how can I give internet connection to my network to these public subnets? Let me go ahead and tell you. So for example, if you need a Wi-Fi at your home or if you need internet at your home, what do? You contact an internet service provider. They basically bring a modem to your home, and then that modem you connect to your Wi-Fi router, and by connecting to your Wi-Fi, you're able to use your internet, right? Similarly, if I want to give internet to my network, what I'll have to do is first I will have to go ahead and request for something called as a internet gateway. So let me create an internet gateway. Let me call it as Netflix network internet gateway. Let me create it. Okay, so it has been created, and now let's see it in a list. So I have created the internet gateway. Now I will attach it to my Netflix network. So here you can see, you can find something called as attached to VPC. Let's click over here. Let's select the VPC that we want to connect to, which is Netflix. Let's select it and let's click on attach internet gateway. Okay, so my internet gateway is now attached to my network. Okay, but still the resources that are going to be in my network, they will not be able to access it. The reason for that is whenever you deploy a resource in a cloud, it is not directly deployed in the main network that you created. It is always deployed in a sub part of the network, which is basically nothing but the subnets that you created. So the subnets that you have deployed, you have to configure them to connect to this internet gateway. Okay, now internet gateway is part of your network, but your subnets are not knowing about that internet network. So uh, in a simpler way, if I were to tell you, You have Wi-Fi at your home, but you are not connected to your Wi-Fi. So your laptop does not know if it can connect to that Wi-Fi or not. Okay. So what I'll be doing now is I will go ahead to something called as route tables. So route tables basically specify which IP addresses can connect to a particular resource in the network and which IP addresses cannot. Okay, so let me go ahead and show you guys how the route table is basically going to be configured. So right now, there is one route table which is automatically created for your Netflix network. Let's call this route table as the internet route table. So whichever subnets or whichever part of the network are going to be connected to this route table will have internet access. And let's create a route table which is called non-internet route table, right? And let's also deploy it in the Netflix network only. So this route table that I have created over here is going to have all the resources which do not have internet access. Okay, so to this non-internet route table, let's go ahead and attach the subnets which will not have internet, and to this internet route table let's attach the subnets which are going to have internet. Okay, so first let's attach subnets to the internet route table. We'll click on subnet associations, and here as you can see there are no subnets attached to it as of now. We'll click on edit subnet associations and we will attach all the public subnets where we need internet to this route table. Okay, so now the route table have been attached, the subnets have been attached to this route table. And now what you will do is you will specify a route to the internet gateway in this route table. And then what will happen is all the subnets which are connected to this route table will be able to see that internet gateway. Or in other words, whichever laptop is at your home will be able to connect to that Wi-Fi. Okay, so let's click on edit routes. Let's click on add a route. And here, let's say everyone in this network should be able to connect. So when you have to say everyone, you give a destination or IP address like this. Okay, so all the IP addresses which are there in this subnet should be able to connect to my internet gateway, which is this, right? And let's click on save routes. So now what have we done? Let's revise. So we connected two subnets to this route table, which basically I named them to be public subnets. And these public subnets, I have given a property to them that they can connect to the internet by using an internet gateway. Okay, so now that we have one network which is going to have internet with us and the other network which is not going to have internet with us. Now what I'll be doing is, so I think I've not connected the subnets to my non-internet route table. Let me go ahead and connect. I'll go to subnet associations of my non-internet and let me connect the private subnets to it. So private 2A and private 2B. Let me connect. Okay, so now I have the two route tables configured and I have my network configured in the fashion that I've just explained to you guys. And now one final setting that we will have to do is we will go to subnets. Now the resources which can talk to each other on the internet or which will basically have internet access, they will need a public IP address as well. If they don't have a public IP, be outside from the Netflix network will not be able to talk to them. Okay, so how do we configure our resources which are being deployed in the public subnet to have a public IP address? This is a small setting that you have to do. So you will be clicking on your public subnet. You will be going to actions. You will have to go to modify auto assign IP settings. Click on enable auto assign public IPv4 address and click on save. So now all the resources which are going to be deployed in public 2A are going to have a public IP address. Public IP address is basically an address which can be reached out from the internet. Okay. All the 10.1 IP address ranges that I specified earlier are basically going to be a part of the local network, that is the Netflix network. But when we talk about the internet is also a network, right? So internet also has its own IP addresses which are given to people when they want to connect to each other, right? So for example, if I am connected to the internet, if I go ahead and see what is my IP address, this is the IP address that I have, right? And this IP address is basically given to me by my internet service provider. So similarly, if I want to deploy a resource on AWS which is connected to the internet and to which I want to connect to, it should have this public IP address. Okay, so that is what we have configured, that all the resources in my public 2A will have a public IP address, and even in public 2B, I will specify that they can have a public IP address. Okay, great. So now all the resources that I'm going to deploy in public 2A and public 2B will have an IP address. And now we can simply go ahead and go to my service EC2, which we talked about earlier, which is going to rent me servers. I will go to that service. And let me deploy some servers now. So what I'll do is I'll click on running instances. And let's click on launch instance. Okay. So the moment you click on launch instance, now let's see what are the kind of options that we see on the screen. So now when you want to rent a server from cloud, the first thing that you need to decide is what is the kind of operating system that you want to run on that server. Okay. So let's say I want to run a Linux server. So let me select Ubuntu. I want to run the Ubuntu operating system on my server. Okay, so I'll select it. And now it will ask me what is the kind of processor, what is the kind of RAM do you want for your server. So here's a list that you can select for. Now, if you want your server to be a part of free tier, you can see this green highlighted text over here which says free tier eligible. Select that. It will give you 1 core CPU and it will give you 1 GB of RAM. Okay, let's go ahead and click on next. Next thing it will ask you is what network do you want to deploy this resource in. So I want to deploy it in my Netflix network, right? And since this is going to be a public instance that I'm deploying, because first what I want to do is I want to configure my server that I'm deploying on AWS, and later I'll shift it to a private network where we will not be able to access it from the internet. Okay, so I am going to deploy it in the public subnet as of now, and what I'm going to do is rest I'm going to leave everything at default. I'm going to click on next. Now it will ask me what is the kind of space or what is the hard drive space that I want for my server. So when you deploy a Linux server, it has minimal requirements. So a Linux server with 8 GB of RAM will work, 8 GB of storage space will work. So I'll just click on next again. And now this is the place where people were referring to, will it have any firewalls? So when you talk about firewalls, you basically are referring to security groups in AWS. Okay, so my instance will basically, or my servers will be governed by a firewall which is called security group, and I can create a firewall or I can choose an existing firewall as well. So when you create a new network, what happens is automatically there's a firewall which is created, which is basically called the default firewall. So it's called the default VPC security group. Okay. If you select that firewall, what are the kind of things that you can configure over here? Let's see. So first of all, what you can configure is the kind of traffic which is allowed in this firewall. Okay. So right now now it says all traffic is allowed. Good. What protocol is allowed? All protocols are allowed. Okay, so we'll have to restrict this firewall in a little while. We'll do that. What port range is allowed? Any port from any traffic is allowed. Okay, and who can connect to this firewall? Only the people who are part of this security group can connect. So this we will have to change, since I want to connect to the server to configure it. So I will have to put my IP address over here in the source. We'll do that in a little while. But for now, this is the firewall that you all were referring to, right? And this is something that we are choosing as default over here. You can create it as well. If you create it, you will again get the same options, but you will have to configure them. Okay, so let's click on review and launch. And now you can just review all the settings that you have done. If everything looks good, you can just click on launch. Now, AWS as a security option, it does not give you a simple password-based authentication to your server. What it gives you is a file which you can use to connect to your server. Okay, so that file is basically called a private key file, which you will have to download from over here, right? So I have a file that I already created. It's called Mac Oregon. So I'm going to select that. I already have it on my system. If you don't have it, you're creating it for the first time, you will have to choose create a new key pair. Let me create it since we are doing it over here. Let's specify as Netflix demo. This is the file that I will be using to authenticate to my servers. Once you specify the name, just click on download key pair. This will be downloaded to your system, and then later you can use it to connect to your server. Okay. Now I click on launch instances. And with this, my server has now just been launched. Okay, and I've launched it inside a public subnet. Okay, so now I've just launched a server, right? And this server is now a part of my public subnet, which means this has internet access. So let's see what all things we have available for this server. So let's call this as Ubuntu server. Okay, so this has a public IP address. Great, I can use this IP address to connect to this server, right? It has the private IP. Private IP is basically the IP which is given inside the network. So as you can see, the range is 10.1, which is exactly what we specified, right? It is a part of the 2A data center, which is good. The firewall attached to it is default. So we will have to change the default rules for this firewall. And others you can verify whatever you configured, exactly those configuration you can see for your server over here. Okay. Now what I'll be doing is I will be selecting the security group, which is the default security group. And let me change the settings over here. So first of all, I'll be changing the inbound rules. So the inbound rules of my firewall right now are these. So let me change this. So I'll click on edit inbound rules. And now, first of all, let me tell the server that only I can connect to it. So I will specify my IP. And as you can see, this is my IP address that has been specified. So only my system will be able to connect to this server. And right now you can see this is the public IP that has been attached to my firewall. Okay. So any kind of traffic from my IP address will be allowed to this server. Okay. So this is the setting that I'm specifying right now. I'll click on save rules. And this setting is done. Now this will be changed later when we will be deploying our full stack application. But for now, this is the IP range that I have specified. Okay. Now I'll go back to my dashboard, go back to my server, select the server that I want to connect to. So this is the Ubuntu server. So you will notice I have some other servers, EC2 demo, which have been created over here. So this account is used by a lot of people. So you don't have to worry about the other servers which are being launched. Just select the server that you want to use. So in my case, it's Ubuntu. Now I'll be connecting to it. Okay. So this is the IP address that I'll be connecting from. Let's copy it. And now to connect to it, I will make use of my terminal. Okay. Now here is something that will be different, that can be different on your system, what is different on mine. So I am using a Mac operating system. So I have something called as a terminal, right? So this is a bash terminal that I'm going to use to connect to my server. Okay. Now, when you might be on a Linux, you might be on a Windows system. So in that case, if you want to connect to your server, you will have to basically make use of a software called Putty. Okay. So there's a software called Putty, which will basically make you to connect to your server, right? So what we basically make use of is the SSH protocol to connect to a Linux server. So this tool, the Putty tool, will help you connect to your server using the SSH protocol. So just click on the first link that you see. You can see it says you can download Putty over here. Just click over it. And here you can download, the Putty version. So you have to download the 64-bit version. In case your processor is 64-bit, if you have 32-bit architecture, then you will be selecting the 32-bit version. Okay.
Okay guys, a quick info, if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Once you download it, there is one more software that you have to download, and that is called PuttyGen. Okay, download this as well on your system. Now, once you have PuttyGen and Putty downloaded, what you have to do is, you remember the key pair file that you got? This is the PEM file. This is the key pair that you got, and this is only for Windows system that I'm telling you right now, guys. So this PEM file is not compatible with your Putty software. Okay, so what you have to do is you have to convert this PEM file into PPK, and that can be done using this PuttyGen software that you will be downloading. Okay, so how you can use the PuttyGen software? Let me show you some screenshots. So this is how your software is going to look like. You don't have to enter any values in key comment key phrase. So what I'll do is, okay. So this is how your PuttyGen will look like when you open it for the first time. So what you have to do is you have to click on load. Okay, it will open a dialog box. Select the PEM file that you downloaded, click on OK, and then click on save private key. Okay, what this will do is it will save a PPK format file on your system, and that is basically the file which you will be using now to connect to your server, right? So PEM files are compatible with Linux systems, but PEM files are not compatible with Windows systems when you're using the Putty software. So you have to convert it to PPK. Okay, so with that done, once you have the PPK file, next you will be opening your Putty software. So your Putty software will look something like this. Okay, this is the UI that you will get. So the IP address of your server will go over here in hostname. So this is my Ubuntu server. This IP address will go over here in this dialog box, the hostname. Okay, so once you put the IP address over here, next what you have to do is you have to click on SSH, right? And once you open SSH, you will find something called as auth under it. Click on auth, and then you will get a browse window over here. Okay, so if you click on SSH, you will click on auth, you will get a browse button over here. Click on this browse button, select the PPK file that you downloaded earlier, and then all you have to do is click on open. That's it. So once you click on open, you and I will be on the same user interface as what I'm going to show you as of now. Okay, so this is the only difference that is going to be there while I am doing this demo and while you will be doing this demo. So first step, you have to convert PEM to PPK using the PuttyGen software. Put the PPK file over here in browse section of SSH auth, and then put the IP address over here by going to session, click on session, put the IP address over here, and finally click on open, right? So now a terminal will open just like this, and then I'll tell you what has to be done from there. Okay, so now what I'll be doing is Let me pass in the command. So this is the command that you will be using when you're on Linux. Okay. So people who are there on Linux, first you have to go to the folder, which will basically have your PEM file, then pass in this command. So ssh-i basically means the server that you want to connect to. Sorry, the PEM file that you want to connect to. This is the PEM file that I'll be using to connect. And then now people on Putty, you will see a dialog box which will ask you for login as. It will ask you for username. So if you have launched a Linux machine which has Ubuntu operating system, the username would be Ubuntu. Okay, Ubuntu @ now when you just have to specify Ubuntu, hit enter, you will be logged in. People on Linux, you have to specify username @ of IP address of your server and then hit enter. Okay, so it will ask you whether you trust the server. This will also be the same for people who are going to work on Windows. You have to type on yes, hit enter, and Windows people will be able to connect then and there to the server. People on Linux will find this kind of a warning which will say unprotected private key file. Okay, so you will have to pass in a command sudo chmod 500, which are basically going to change the permissions of your file, right? And then just change it with 500, and this should do the trick. Now pass in the same command, and there you go. I have connected to my Ubuntu server on AWS. So people who will be doing it on Windows, you will also see the screen as you are seeing right now on my screen, right? And this is how you connect to a server which is deployed on AWS. Okay. Now that we have connected to our server, what I'll do is I will basically make it a web server, and then once our website is ready, we will deploy it in my private subnet, which is not going to have any internet access. Okay, so when you want to create a web server, first thing that you have to do is anything that you want to install on a Linux machine, first you update that machine. Okay, so I'll just type in sudo apt get update. It'll take like a minute to update the machine, or even less than a minute. So it took 10 seconds to update the machine. Now what I'll be doing is, so this is the command that I passed to update the machine, sudo apt get update. Next thing that I'll be doing is I will be installing a web server. So sudo apt get install Apache 2. So this is a web server which is now getting installed. Okay, so I just choose yes. Okay, so web server is now being installed. And after this, we'll do a very cool exercise, guys. So you will be able to see that if I go to the IP address of my server now, so I'll just type the IP address over here in the browser. You can see I can able to access this page in my browser. Okay. Okay. So now what I'm gonna do is, guys, I'm gonna basically go ahead and define a web page over here. So let me show you how we are going to go ahead and define our web pages. Okay. So what I'm gonna do is, this is the architecture that we are going to deploy now. So I will have a separate web page for streaming servers. 1 second. So I will have a separate web page for my video page, and I will have a separate web page for my home page. Now let me show you why we are going to do like this. So let me go ahead and open the website called netflix.com and just see what is the behavior. So if I go to netflix.com, I automatically go ahead and get routed to netflix.com/browse. Okay. And if I select the account that I want to use, it's still the URL over here. It's netflix.com/browse. So netflix.com/browse is taking me to the homepage of Netflix. I hope everybody is clear here. Okay, now what happens if I play a video? Okay, so let me play this series over here. So now what you can see is the URL changed to netflix.com/watch, and then you have some numbers over here, which probably would be the numbers for your video. Okay, so you have connected to netflix.com/watch. One second. You have connected to netflix.com/watch in order to get to this page where it is, playing this video. Okay. Now let me show you what happens when you play some other video. So I'll again click on back. Let me play some other video. So let me play, let's say, this Space Force. Can you still see? It's still netflix.com/watch. And then you have these numbers which are after this URL. So these numbers basically are referring to the video which is playing on this page, but this page is same all the time. The page is always netflix.com/watch, which is basically referring you to this video player. And then to this video player, what you're doing is you're providing this number, which is basically now going to play the video that you are launching over here. Let's see if we remove the track ID, what happens. Okay, so this is the number which is associated to the video that you are playing, right? And this is the page that you're going to. You're always going to netflix.com/watch. So if you go to netflix.com/watch, you open the video player, and to that video player you tell, okay, so this is the video that I want to play, and that is what is being played over here. So let's see if I just type in watch, what happens. Okay, you can see they have routed me to something else because they do not want me to just access the web the video player. So when I go to netflix.com/watch, they basically reroute me to some other URL. But you now understand the working of Netflix. What they do is, if you go to netflix.com/browse, they are routing you to the home page. And if you go to netflix.com/watch, and some video ID if you specify, it will take you to that video which is being played. Okay, so now let's see how we can mimic this architecture on our system. So what I'm going to do is, if I go to netflix.com/home, I will be taken to the home page. And if I go to netflix.com/stream, or let's make it watch. So if netflix.com/watch, if I go to, it will take me to the video player. Okay, so this is something that we are going to configure now, and this we are going to do using the AWS infrastructure. Okay, so first of all, let's create a home page. Let's create a page that we will be routed to if you go to /home. Okay, so what I'm going to do is, this is my web server where I'm able to go and see this page. Let's change this page to look like a home page. So what I'll do is, so once you have an Apache 2 server which is running, you can go ahead in this path /var/www/html, and this will have a page called index.html. Okay, so this index.html page, if you change this, your HTML will change over here. Okay, so for now, let me first delete this index.html page, and now let's create a new index.html page which says, let's say, welcome to home page. So I will create an HTML page which will, this is a very simple HTML code that I'm writing over here, which will says welcome to the home page. Okay, so this is what I've created, and if I refresh over here, you can see it says welcome to the home page. And even you guys, if you refresh, you will be able to see this particular web page which says welcome to the home page. Now our web page, our web server, our home page is now ready, and now what I'll be doing is I'll be deploying this inside a private subnet. So let's see how we can do that. So for doing this, I will first go to my dashboard, and this is the server that I created. So let me create a copy of this server first, and then that copy I will deploy it in the private subnet that we created earlier. So I'll just select the server that I created, click on actions, then you have something called as image. So let's create an image. Image is nothing but it creates a copy of your server which can be deployed multiple times in. So we'll create an image. Let's call this image name as homepage, home, Netflix -home. Let's specify this. Right, let's click on create image, and now my image is getting created. Okay, and that image will basically have this web server already deployed. Great. So now that it is happening, I think it will take a minute or two to create that image, and you can see that image in the under the image section in AMIS. So if you go to AMIS, you can see that a Netflix home image is being created, and it is in the pending state as of now. So I think if we refresh it a couple of times, you can see it will change to available. So let's wait. So while this is happening, let me explain you how the other things are going to work out. So as you must have noticed, right? So if you want to have a home page which is going to be separate, and if you want to have a watch page which is going to be separate, you will be dealing with two servers, right? And if you're dealing with two servers, you obviously will have two IP addresses, right? But as you can see from the behavior of the Netflix website, the URL always remains the same, right? Only the web page is changing. So how do we accomplish that? So we can accomplish it by having a common medium in the middle, which can connect to both my watch page and my home page. Okay, so this resource, which is the elastic load balancer that we're going to deploy in a minute, is going to have a URL which is always going to be the same. And this load balancer we can configure to understand if the URL is /watch or /stream, it is always going to route my request to the streaming servers. Whereas if my request is /home, or let's say just / or just no URL at all, in that case it will be routing my request to the home page. So this is possible using the elastic load balancer, right? And this is something that we are going to go ahead and deploy now. Now I think we are ready to now understand how our architecture is going to be deployed. So now what I'm going to do is all my servers, they are going to be a part of my private subnet where I do not have internet access, right? But as we have known from the previous from our previous understanding, we know that everything within our Netflix network will be able to interact with each other. Okay. So in my Netflix network, I have a public subnet, I have a private subnet. So private subnet does not have internet access. Public subnet has internet access. So in my public subnet, I'm going to deploy my load balancer, right? In my private subnet, I'm going to deploy all my servers, right? And these servers can only be accessed by the load balancer and nothing else. Okay, nobody else will be able to connect to these servers directly. Only through my load balancer, they will be able to access my servers. And this is a very good architectural practice when we talk about having security for our servers. Why? Because you can control which protocols can you interact with in your load balancer. For example, let's say a hacker wants to go ahead and make use of servers. They want to pass some commands as I did on this terminal. Okay, so if you want your load balancer to restrict that, your load balancer will only allow HTTP traffic. What is HTTP traffic? HTTP traffic is the traffic that you get from your web browser. So only the web browser's traffic will be enabled through your load balancer. If somebody is trying to pass some command, if somebody is trying to connect through some other protocol, it will not be allowed. Okay. And even in that case, your load balancer will only allow some URLs. So only if you type in /home, you will be allowed. If you are typing something else, you will not be routed to my server. That again is a very good security aspect, that if your URL is pointing to netflix.com/home, only then you will be reaching my home server to access that content. You cannot access my content and from any other medium from that particular server. Okay, so this is how you can restrict hackers or restrict attackers from accessing your server, and it's a very good architectural practice to have your architectures deployed like this. Okay, as I said earlier, we are inside one network, and the Netflix network that we created, right? That is the big network that we created. Inside that big network, we created small networks, which were public and private. Public had internet access, private did not have internet access. Okay, so all these resources which are a part of the big network, which is Netflix, all the resources can talk to each other. Now imagine this rectangle is my private subnet. Okay, and this rectangle is my public subnet. And what is the difference that I told you between the two is the public subnet has internet access. The private subnet, it does not have internet access. Okay, so if I connect to a server which is there in my public subnet, right? Because I'll be able to connect to it. Why? Because it has internet access. If I connect to a server in the public subnet, I can then connect my private server through this public server, right? If I connect to this Ubuntu server on my terminal like this, and then in this server which is there in the public subnet, if I enter the SSH command again, and I enter the IP address this time, the private IP address of the private server which is deployed in the private subnet, will I not be able to connect to it? Okay, if I have a private machine which is deployed in this private subnet, if I have to connect it from my machine, what I'll be doing is I'll be launching a machine in the public subnet, and through that I will be connecting to it. So coming back, now we have our homepage image ready, right? Now let's create an image for our streaming server as well. So what I'll do is, again, let's create one more image from this server itself. Let's again go back to this directory. Let's change the index.html. and this time let's say welcome to the streaming page. Save it. Okay, and now if you go to this IP address, you will see it will now say welcome to the streaming page. Okay, and now let's create an image out of this as well. So again, we'll go to EC2. So in our Ubuntu image, we'll go to image, we'll go to create image, and let's call this image name as Netflix stream. Okay, so now the image will be created for that as well. Now what I'll do is I will go ahead and launch my home page in my private subnet. Let's see how we can do that. So I click on launch instance and I will choose my AMIs over here. I'll not choose any operating system now. I'll just choose my AMIs. And now I will choose the Netflix home image, which I created earlier. Let's select it. I want to launch it in the free tier server. Everything is going to be the same that we did earlier. Just that now I will be selecting a private subnet which I'll be deploying it in. So I'll be choosing the private 2A network. Let's deploy it over here. And this is our home page that we're deploying. Security group, we will select again the default security group. And we're going to restrict it. Don't worry about that. We're going to restrict that security group. And let's choose the same key pair that we used earlier, Netflix Demo. Acknowledge that we have it and click on launch instances. So this is now getting launched in US West 2A. It's going to be launched in the 2A data center. This is basically now called Netflix-home. This is the home server that you have launched, home page that you have launched, and it will take a little while. And as you can see, it is now running. Now, if you have a look at the settings of this server, you will see that it will not have a public IP address, right? Why? Because we deployed it inside a private network, right? But it will have a private IP address. But this private IP address can only be reached out within the network. It cannot be reached out from outside of the network. Remember this, okay? So this is the IP address that we will be connecting through from our public instance, which is nothing but this instance that we connected to earlier. All right. Okay, so we have launched our home page. Now let's go back. Let's see if our streaming page is ready. So even streaming page is now ready. Let's launch this as well. So I'll just select the streaming image, click on action, click on launch. This is another way of launching it, right? This is the server that I want to launch. I want to launch it under the free tier. It will be deployed in the Netflix network. And this time I'm going to deploy it in private 2B data center. Okay. Everything else going to be the same. Security group, I'll select the default one. Click on review and launch it. Select the same key pair that I selected earlier, acknowledge that I have it, click on launch instances. And with this, my streaming page.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Has also been launched. Okay, great. So now I have two servers which are now deployed inside private subnets, and as you can see, I do not have a public IP address over here. Okay, and hence I will not be able to access them from the internet. These are not having any internet access, and I will prove it to you in a little while. Okay, so I have the home page which is now running. I have the stream page which is now running. I have let's name it as proxy server. So I have a proxy server which is running in the public subnet, which has internet. Now what I'll do is, using this proxy server, I will be connecting to this home page and the stream page server. So let's see how we can do that. So first we need to copy the PEM file that we have on this proxy server. So let's copy it. So the way you can copy it is, use a command called scp, which is called secure copy. So first you will have to authenticate yourself using, the proxy server's PEM file. Then you will have to specify the file that you want to copy. So the file name is again this PEM file I want to copy, right? Where do I want to copy it? I want to copy it on the proxy server, which is this IP address. And I want to copy it in this particular file location, which is /home/ubuntu. Hit enter. Since I specified sudo, it is asking me for my computer's password. Specified that. And now the file has been copied successfully. So now if I SSH into my server again, you can see that the file has been copied, netflix-demo.pem. It has been copied onto my proxy server or my public server that I launched earlier. Okay. Now people on Windows, if you want to do the same, what you can do is follow a simpler method. You can download a software called FileZilla. Okay. So FileZilla helps you to copy files from your local system to your specified server, right? The next thing that I will be doing is I'll be connecting to my private server. Now, where is my private server? My private server is this. Let's connect to a Netflix home server. Okay. So Netflix home server, this is the IP address, the private IP address for my Netflix home server. Let's try to connect to it. So I will be typing in SSH-I and then the PEM file, the username, and then the private IP address. So as you can see, earlier my IP was 10.1.1216. Now it has changed to 10.1.3.193. And that is the IP address of my Netflix home server. As you can see, the private IP address of my Netflix home server is 10.1.3.193. So this basically means I have successfully connected to my private instance. Now, for some of you who still have a doubt whether, if I pass this on my local machine, what will happen? So right now I'm inside the AWS server, right? But let's say, this is the terminal for my local machine. If I pass the same command over here, okay, first let me go to the folder which has the pen file. Okay, so if I pass in the same command over here, you will be able to see it will not recognize what this address is. Can you see it's not connecting? It's not doing anything. Why? Because it does not know what this IP address means. Why? Because my local machine is not a part of the Netflix network, which is there on AWS, right? But this machine is, and that's why when I passed this command, it was able to connect to this Netflix home server. Now, what I'll do is I'll just check if the web server is running. Yes, so it is active, it is running. That means if I curl, so this is something that I'm just doing for my checking, guys. If you don't understand, it's fine. Okay, so that means my Apache server is working on Netflix home, which is great. So let me just exit. So I've exited, and now I'm back to my public server. You can see the IP address changed. And now let me log into my Netflix streaming server as well. So I'll just change this IP address to my stream server. So my Netflix stream server has the IP address as 4.167. Let's specify that. So as you can see, I have connected to my Netflix stream server now. And if we check if the web server is running over here, yes, it is running over here as well. Great. So both my servers are running fine, and I've just showed you how to, if some maintenance is required, how to do maintenance on your private machines. Right now, what I can do is once maintenance is done, I can just delete this proxy server, and then I'll not be giving any access to my uh, private machines. One thing that I forgot to show you was, let's say this is my public machine that I've launched on right now, right? This is my proxy machine that I've connected to, right? This has internet connection. How do we know that? First of all, we are able to access it from my local machine. At the same time, if I type in curl google.com, you can see that there is a response that I get, right? But if I, let's say, go to my private machine, right? And if I do a curl google.com over here, you can see that I'm not getting any response over here. Why? Because this machine does not have internet access. Okay, and this proves that. Great. Let me exit. And now that our web servers are ready, they are ready inside, a private subnet. Let's configure our load balancers to connect to this machine. Let's create a load balancer. So I'll just scroll on my EC2 console, and I will be able to see something called as load balancers over here. Let's click over it. So let's click on create a load balancer, and I will be creating an application load balancer. So application load balancer basically works on the application layer, and it basically helps us to do path-based routing, which is something that we are trying to accomplish, which is if I go to netflix.com/stream, I should be going to my stream server. If I go to /home, I should be going to my home server. So we'll be creating an application load balancer. Let's name it as Netflix-demo. This is going to be an internet facing load balancer, right? And the protocol that we are going to use is HTTP protocol. Okay, so here, as you can see, this is very important. So the only protocol that this load balancer is going to allow is HTTP protocol, nothing else. All right. Which VPC will this load balancer be a part of? It will be a part of the Netflix VPC, and this has to connect to 2A and 2B servers, private servers. So if they have to connect to private servers in 2A and 2B, this load balancer has to be deployed in public 2A and public 2B. Only then it will be part of the network, and then it will be able to connect to your machines. Okay, so what is the configuration that we did here? So you have configured your load balancer to connect to your private machines only using the HTTP protocol, nothing else. Okay, let's configure the firewall for this. So firewall, we'll be using the default firewall only, will not be making any changes. Let's specify routing now. So for routing, you will have to specify which servers to connect to, right? So right now, let's go ahead and specify a target group. Let's name it as public-server. And now let's go ahead and specify the public server IP address. So the way I can do that is by specifying the servers that I'll be able to connect to, right? So what I'll do is target group is nothing but the set of servers that you can connect to, right? So let's specify the name of this to be, let's say this is the home page server, right? Let's click on next. And now what I can do is I can select the home page that I want to connect to. So this is the home page that I want to connect to. And let's click on next again. So this is the target group. that I've just created for my home server. I'll be creating one more target group. Don't worry about that. So let me first create it and then I'll explain you what I've just done. So let's create this load balancer now. Okay, so load balancer is now created. Next thing that we will be doing is we will be creating one more target group. So we have created one target group for homepage server. Let's create one for streaming server. Okay, this streaming server will also be a part of the Netflix VPC. And now let's go ahead and click on create. Okay, so now my target group has been created. So I have a homepage server and now I have a streaming server as well that I would want to connect to. And in this, so homepage server should have the homepage server connected to it. So it is not connected. Let's connect the homepage server over here, which is Netflix home server. Let's register it to this target group, save it. And similarly, in my streaming server target group, let's connect our stream server, register it, and click on save. Okay, so both of these now have the targets attached to them. And now what we can do is, now we will be specifying the rules for our load balancer. So let's go back to our load balancer. And now what I can do is, so now I have to specify this routing rule, which is if I go to /stream, then it should connect to the target group of my streaming server. And if I go to /home, it should connect to the servers of my home server, the server of my home page. Okay, so let's see how we can configure that. Okay, so you will have to go to listener and then you will have to specify rules. So let's go ahead and edit these rules over here. Okay, so right now what is happening is anything which is going to this server, it will be routed to the home page server. Okay, so let's add a route over here. Let's click on insert rule and add a condition. So we'll be adding a condition for a path, and the path will be if it goes to /stream or let's say /watch, right? It should then forward this request to the streaming server. All right. So if the path is /watch, the request will be forwarded to the streaming server. Okay. If there is no path specified, it will be routed to my homepage server. If there is, let me specify one more thing. So let me first save it, right? And let us add one more rule. So if the path is /home, okay, let's try and see if this works for us. So if I'm going to /watch, yes. So the star was missing over here. So now if I'm going to my load balancer /watch, I'm going to the streaming page. And similarly, what I'll also have to do is, let me exit and let me go to my home server as well. Okay, so here as well, I will have to add a home directory. Let me quickly do that. Okay, and now if I go to my load balancer, let's say I'm going to /home, you can see I'm being routed to the welcome to the home page. And if I'm just going to the URL, then also I'm being routed to welcome to the home page. Okay, so now what we'll be doing is, now we will be connecting a custom URL to our load balancer. And so first things first, what you need is a URL first. So what you need to do is just go to your Freenom website. So there's a website called Freenom. It basically gives you free URLs. Okay. So just sign up on Freenom. Okay, I'm connected. Let's go to my domains. So right now I have some domains, but I'll be showing you once you sign up, how you can create your own domain. So what I'll be doing is, as you can see, these are some domains that I have. I'll be creating a new domain, just like you guys would be doing when you sign up. So I'll just go to register a new domain, go to services, go to register a new domain. And in register a new domain, just specify the name of the domain that you want. So in my case, I want Netflix-demo. Let's check the availability. So as you can see, these are all domains which are free and I can get them. So let's get this domain, check it out, continue. And just agree to the conditions and click on complete order. So with this, your order has been confirmed and you can now go ahead to my domains. You have the Netflix demo domain registered to you. You can just click on manage domain. And here you will have to go to click on management tools and then click on name servers. Okay, and what you have to type in is custom name servers. So these are some name servers that you have to fill in. Now, how can you fill these name servers? Again, go back to your AWS management console, click on services, type in route 53. Now, once you're inside route 53, you will have to choose a hosted zone. Let's click on create hosted zone. And over here, just type in the domain name that you created. So it's Netflix-demo.pk. Give the same name over here, click on create, and this will create a hosted zone for you. Now, as you can see, these are name servers that you will have to enter over there in Freenom. Okay, so just select this, copy these name servers one by one. Go to the second name server, again copy it from here. Third name server, again copy it from here. Fourth name server, again copy it from here. Okay, so that's all the changes that you have to do on Freenom. You can close it now. Now in route 53, you just have to do one small change. Click on create record set, right? And now what you'll be doing is you'll be pointing. So what have you done so far? You have mentioned these name servers in your Freenom website, right? So now your domain will be pointing to these name servers, which are basically the route 53 servers that you have. Now this route 53, you will have to point to your load balancer. So how will you do that? You will find this section called alias, click on yes. And here you have to select your Netflix demo load balancer. Okay, click on create. So entry is made over here. Similarly, one more entry you have to create with the similar settings, just that in name you will have to enter www as well. Click on alias yes, select the load balancer, click on create. Okay, so with this, now your Route 53 is ready. And now what you can do is just go to a browser, type in netflix-demo.tk, hit enter, and it will now route you to the home page directly. And now if you go to the URL /watch, it is now pointing you to the streaming page. And this is exactly what is happening on your Netflix website as well. So let me quickly show it to you. Okay, so if we go to netflix.com/browse, it will take you to the home page. If you type in netflix.tk/home, it will take you to the home page. If you type in netflix.com/watch and then the video title, it will take you to the video player, which will play the video file for you. And similarly, if here you go to netflix.com/watch, you will be taken to the streaming page. And guys, this is how you mimic the architecture for Netflix on AWS.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Okay, so we've seen that. First of all, before going into the certification details, I'll explain what is AWS DevOps. So AWS is a cloud platform, fine. DevOps is a methodology to automate the software development lifecycle. So how does these two come together? So first of all, to create software, to build software, you need tools. To release software, you need tools. For every single process, you need certain tools. So using AWS, you can launch servers in which you can build your software, you can test your software, you can push your website into, and you can host your application over there. You can do every single operation in AWS. So now an AWS DevOps engineer will specialize in using AWS for DevOps. That is, this particular person who is an AWS certified engineer will know how to use AWS, how to use DevOps, and also other tools. So under DevOps, let's say tools like GitHub, then there will be tools like Jenkins, there will be tools like Nagios for monitoring, Xdeploy, and then there is Chef, Puppet, Ansible. So this particular person should know all these tools as well as AWS services. Only then he can or she can clear the examination. So that examination's code is DOP-CO1. So this is the code for the AWS DevOps certification. So I think you would have understood. So DevOps is basically automating the software development lifecycle. Now, if you're doing that with the help of AWS, then you can go ahead with the AWS DevOps certification. Okay, so first of all, what is it? The AWS Certified DevOps Engineer -Professional. So this is DOP-CO1 exam. This is intended for individuals who perform a DevOps engineer role with 2 or more years of experience provisioning, operating, and managing AWS environments. So I'll tell you this. First of all, you cannot directly become a DevOps engineer because you should have worked in the IT profile. Only then you can move ahead with DevOps engineer, because every single role in DevOps engineer requires certain experience on using GitHub or other DevOps tools which that particular company is using. Okay, so that's what I wanted to convey over here. Then, so to clear the DevOps certification, what should you go through? So they have content domains and their ratings. So there are 6 main domains which you'll have to concentrate on. So this is not randomly taken values. These are taken from the official guide provided by AWS. So for the AWS DevOps certification, so you can check that out online. You can just type in AWS DevOps certification and you'll get the official site. You can go in and download the guide and check it for yourself. So under this, there is SDLC automation, there is configuration management and IAC, which is infrastructure as code, monitor and logging, policies and standards automation, incident and event response, high availability, fault tolerance, and disaster recovery. So that percentages are the weightings of questions in the examination. So if there are 100 questions, there would be 22 questions from SDLC, 19 questions from configuration management and infrastructure as code, and the others. So I think you got the idea of how this works. Okay, so first of all, SDLC automation, which is basically software development lifecycle automation. You should know all the tools required to do that, maybe in AWS as well as other DevOps tools like Docker, Kubernetes, Jenkins. Then configuration management and infrastructure as code. So configuration management basically deals with tools like Chef and Puppet. So you use this to manage the configuration in all the servers. So let's say you have 10 servers having the same application. So all the 10 servers should have the same configuration, right? So you can use a tool like Chef. So you can create a master and all the other servers will be your slaves. So what you can do is, this master should be connected with all the other slave servers. So once that is connected, you can upload the configuration file to the master. So the master will take care of master will take care of making sure all the servers connected to that are having the same configuration. So this is what configuration management like simply is. This is not the whole thing. And then infrastructure as code, where you can create a JSON file which you can use to create a complete architecture. So if I go deep into this will take a lot of time. I'll give you a basic idea about this. So first of all, SDLC automation, configuration management and infrastructure as code. Then monitoring and logging does not come third. Third comes incident and event response. So I'm saying third in the percentage, that is the weightings. Okay, so incident and event response in the sense there would be a lot of troubleshooting. So because you will have to, whenever there is a bug, whenever the application is down, you should know how to respond to that. You should know how to solve that. So that comes under. And then comes high availability, fault tolerance and disaster recovery. So first of all, high availability in the sense the application which you are hosting online should be always available for the customer. It should never go down. Even if it goes down, it should come back up immediately. Fault tolerance and disaster recovery. So when you have an application hosted in a particular availability zone, if there is a, let's say there is a calamity happening over there, let's say there is a huge storm and the data center is completely off and you cannot host your application over there. So you should have a replication of your entire application in another availability zone for this particular issue, so that when the application goes down over here, we can start off the application over there. So basically recovering from a disaster. So once this availability zone comes back up, you can go back to using this. And then comes monitoring and logging. So you need to know how to monitor all your essential tools required for SDLC automation. You should know how to monitor your complete software development lifecycle in a single go, and also logging. And then comes policies and standards automation. So this is mostly theoretical. You should understand the policies and the standards of automation of the company you are in, as well as the regulations. So the thing is, to automate any software, you will need certain policies that this should happen and this cannot happen. So you'll have to figure out what is that, and then you'll have to work towards that. Okay, so these are the basic content domains and their weightings for the AWS DevOps certification. So now the recommended AWS knowledge you will need to clear this particular certification: 2 or more years of experience provisioning, operating and managing AWS environments. So to clear this particular examination, the recommended AWS knowledge given by AWS themselves is you should have at least 2 or more years of experience working on AWS. And then comes experience developing code in at least one high-level programming language. So only if you know to program and create applications using it, only then you can easily understand the SDLC process. So that is required. experience building highly automated infrastructures, that is creating let's say again an SDLC lifecycle which is automated, or a DevOps lifecycle. Then experience administering operating systems. So this is basically monitoring when there is an issue, when there is a when there is a problem, troubleshooting it, and understanding of modern development and operation processes and methodologies. So this is, let's say you're using a certain tool, and in the market there is a new tool which will make that process much simpler, but if you don't understand how it works, then you cannot take that up. So let's say you're using Jenkins, and suddenly there is a new release called Jenkins 2.0 which makes the CI/CD process much simpler, and you're still using Jenkins for SDLC lifecycle, and sometimes that might not be appreciated because you should adapt to the modern development, and if there's a much easier way of doing something, you should move towards that. Okay, so this is the recommended knowledge. Now the DevOps learning path to attain the AWS Certified DevOps Engineer Professional Certification. So the thing is, there is no prerequisites to take this up. You can directly take up the AWS Certified DevOps Engineer Certification, but it is not recommended because it's a very advanced examination, and the recommended path to get the certification is provided by AWS. So you can check this path out. First of all, you can take up Certified Developer Associate or the SysOps Administrator Associate certification by AWS and get that certification by clearing those exams. So you can do this in your first year or second year of your job. So once you did this, you can either take up a DevOps engineering on AWS or advanced developing on AWS courses, so you can learn how this actually works in the real-time industry. And then you can take up a practice exam on DevOps engineer before taking up the actual exam. So DevOps engineer exam readiness exams are pretty cheaper than the actual exam, so you can take that up, and if you're confident enough, you can give a go to the AWS Certified DevOps Engineer and you can get the certification. So this is a simpler path, but this will take a lot of time to achieve if you're going to take up this particular path. Okay, so you can take this up. Next, the examination details for the AWS DevOps certification. So you can see here the examination is multiple choice, multiple answer. It is a professional type. Then the delivery method is you can take it up in a testing center. And right now, as you know about the COVID situation, there is an online proctored exam as well. You can take that up. And then time 180 minutes to complete this particular exam. Cost 300 USD. If you're taking it up, if you're taking the practice exam, it is 40 USD. You can also, as I told you, this is for professional. If it is an associate certification, which is AWS certified developer, the cost of the examination would be 150 USD and the time would be 130 minutes, and practice exam cost would be 20 USD, and the languages available will still be the same, which is English, Japanese, Korean, and simplified Chinese. Okay, so these are the exam details and this is the learning path. Let's move ahead to AWS DevOps Engineer, roles and responsibilities. So first of all, so let's say you have learned everything you need to know about AWS DevOps Engineer. Then if you want to become an AWS DevOps Engineer, you should understand the roles and responsibilities of one. So first, who is the AWS DevOps Engineer? So an AWS DevOps Engineer will design and develop automation using AWS and other DevOps services to support the CI/CD workflow or the DevOps workflow. So to be very simple, an AWS DevOps Engineer will create an SDLC, that is a software development lifecycle, using AWS and other DevOps services together. Okay, so we saw this, who is a AWS DevOps Engineer. So I think you would have understood that point very easily. Now coming to this, now let's check out some AWS DevOps job descriptions. So these are two job descriptions which I found and we'll compare this. First of all, this is an AWS DevOps senior engineer job description. So at the very beginning, you can see, don't process any profiles without the below must have skills. So these skills below, which are must have, so not must, good to have is not a problem. It's not required that you know those tools, but in any job description you should know the tools which are provided in the must-have section. First of all, code repositories, GitLab is must. Runner, Bitbucket configurations tools. Then you should know Docker, you should know Chef, Ansible, so Bash scripting, Groovy. Then under AWS services, you should know ECS, Fargate, Lambda, SNS SQS, CloudFront, Code Build, configuring CloudWatch, Secret Manager, Active Directories, Serverless Application Model, Service Catalog, Kubernetes. And then comes Jenkins, Maven, NPM automation, and then Rundeck. So these are for CI/CD. Those are AWS services. Those are the Docker and code repositories. So these are some of the must-have tools, and you can see there are a lot of AWS services and DevOps tools involved together for an AWS DevOps senior engineer. And then this again is an AWS DevOps architect. So under this you can see the job description is pretty simply provided. First of all, implement and stay abreast of cloud and DevOps industry best practices and tooling. So this is basically theoretical. You should know how the cloud industry and the DevOps industry is moving ahead. And then also you should be an expert in these three tools: AWS Code Commit, AWS Code Build, AWS Code Deploy, as well as AWS CodePipeLine. So these are developer tools provided by AWS. These are not separate DevOps tools. So I just wanted to show two different JDs to show how much it varies. So basically it is dependent on the company you're applying for. So in this company, right, if you want to take up, you should know all of these tools. If you want to take up in this company, which is GroupSoft, they have provided you should be an expert in 4 main tools: Code Build, Code Commit, Code Deploy, and Code Pipeline, and also good communication skills. Obviously that is needed for any job. Okay, so we've seen the job descriptions. You can go ahead and check out job descriptions in various job portals like Indeed, Glassdoor, let's say Monster. You can check that out. You can figure out what tools you know and what you'll have to learn, and then you can register for an application. Okay, so you've seen that. Now, what are the companies which are hiring DevOps engineers right now? So before taking up this session, I looked into companies who are currently hiring for DevOps engineers. So it's pretty simple. Just go to Google and type AWS DevOps engineer or Azure DevOps engineer or just DevOps engineer, because any DevOps engineer would require to learn cloud tools. So if you're just searching for a DevOps engineer role, even then you should understand the basics and know how to work with AWS. So these are the top companies which are hiring currently for DevOps engineers. Anyone who is aspiring for a DevOps engineer job, you can go ahead and apply for those jobs and go ahead with the interview. So there is SAP, there is Paytm, Amazon, Oracle, and Dell who are currently looking for a DevOps engineer. But you should remember this: all of these companies require an experienced DevOps engineer. So do not apply if you're fresh. Don't apply if you're a fresher. Just take up a developer post or any other software engineer post, then move ahead with DevOps engineering. That would be a better career choice. Okay, so now we've seen that. Now you might also have a question of what are the services should I learn, because we saw various different job descriptions and it had contrasting tools which you'll have to learn. So let's see what are the main tools you'll have to learn. First of all, in AWS DevOps, these are the top developer tools provided by AWS themselves. So you learn Code Commit, Code Build, Code Deploy, and Code Pipeline thoroughly. So learning these tools is important. Then comes the AWS services and the DevOps engineer tools. So under AWS services, learn every single tool if you want to, but there are hundreds of tools and you cannot learn all of them. So take up 10 or 15 services which are extremely important for a DevOps engineer role, such as EC2. EC2 is basically a server creator. You can create servers, maybe Linux or Windows. And then Amazon RDS is a relational database service where you can create databases. That is also required for any company who develops software. And then Amazon EBS is for volume. Amazon Direct Connect is for connecting the cloud, the cloud architecture with your on-premise setup. Then there is S3 for storage, Elastic Load Balancing for balancing your website's load. And then Route 53 for routing, it's basically a DNS server. And then Amazon VPC, it's more of an AWS concept in which you can create virtual private cloud. That is creating a network within the cloud so that all the resources within that particular cloud is not available for the public. And elastic IP address is basically an IP address which you can use to locate your server, which is the EC2 server. Okay, so these are the services in AWS, and you can see the DevOps engineer tools. First of all, you'll obviously need to know a source control tool, either it's GitHub or Atlassian's Bitbucket. So let's say that company is using the Atlassian ecosystem, go ahead with Bitbucket. If not, GitHub is the most commonly used version control tool. And then configuration management, Jenkins is a CI/CD tool as well, and Jenkins and Puppet, Chef, you can take that up. Ansible, learn all these tools. For cloud, learn both of AWS, Azure. If you want, you can learn GCP as well, or take up any one of these cloud tools, either AWS or Azure, and go ahead with that. And then comes Docker, LXD for containerization, and for orchestration comes Kubernetes. So containerization, again, you'll have to go ahead and learn DevOps, only then you can understand these concepts. But just remember this, you'll have to learn Docker, very important. Kubernetes is very important. Okay, so these are the services which you'll have to learn if you want to become an AWS DevOps engineer. So AWS, given that, you should learn the AWS services as well as these 4 tools. And then you should also learn other DevOps tools like GitHub, Docker, Kubernetes, Jenkins, Puppet, Chef, Nagios, and there are so many DevOps tools which you can learn from. But again, don't learn all of those tools. Take up certain tools and learn them thoroughly.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
So our first question asks us, can we explain the Git architecture? Now this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right. So let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. And this is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code. You committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right. So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes, and the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert, and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I've not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
All I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed. Right now, if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, if you are now, when you work with people commit mistakes, But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically a disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where, a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically there are softwares like Hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like Hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on this same hardware by virtualizing the hardware so as to the operating system will feel that say if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically, once you have virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with the given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay. So we have come back to our AWS server. Let me clear the screen. All right. So if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, So I'll do a docker exec -it and then bash. Docker exec -it and then I forgot the container ID, so the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a PS AUX, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the $ prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a DockerFile used for? What do you basically use a DockerFile for? So a DockerFile is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Dockerfile, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var/www/html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file, which will basically build this image for me without me having to do all these things, all these manual things, which I just told you. All right. So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it -p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID, and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's on exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a DockerFile, and what I want to say is in the image shhar/web app, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay, this is where I want to add it, and inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor, and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with. In those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job. right? There are a lot of dependencies for Kubernetes. You'll have to see the system, you'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git. Like we took that example, when you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins does. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right, but before going ahead, let's see what is the architecture for this kind of a thing. All right, so this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the DockerFile as well. Okay, so we created a DockerFile inside. Okay, so here it is. So we have our DockerFile created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this DockerFile? We saw that we could create a DockerFile using, if we write something like this in our DockerFile, and this would basically create an image with our code which is there on GitHub. All right. So what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a DockerFile. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a DockerFile in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the DockerFile. Now where is that DockerFile? The DockerFile will basically be downloaded in the Jenkins workspace. So that is in var lib jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this I will have my Dockerfile, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p, and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do these this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we are building this Docker file and we are naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ, and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay, and I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to our remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check what are the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed, and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master. Enter the credentials. Great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master. Enter the credentials. Everything has been pushed. Job is getting triggered. Job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome, guys. So we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have, say, around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the three top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based, and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, It's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have has that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team. What softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right. But if you talk about the architecture or the working or the life cycle of how this actually works, on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right. So in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right. So our next question says, create an Ansible playbook to deploy Apache on a client server. So basically we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay. So let me quickly do an SSH into my AWS machine. And what I'm going to do is I have a slave machine which I have already configured, which can interact with my master.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay. Now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified APT. Basically I want to use the APT package to install Apache 2, the latest software. Okay, now what I will do, I will type in Ansible -playbook, and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows, or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. you'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
All right. So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right. You have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You are basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity. Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now you can think of it as, say you want a deep learning AMI, or you want a Windows Server AMI with specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS marketplace. So the answer for this is AWS marketplace. It's basically a place where you can buy all the AWS systems that you or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D, you will not even consider. Reason being that you're talking about the log of the client information, right? What all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question, the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer, reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says, you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. Alright, so the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want to basically we want to track user data, right? So SNS would not be the apt choice for it, because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice, because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time, right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are auto-scaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances in one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones and we could deploy 2 servers in each, and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use Elastic Cache and in what cases? All right. So the answer for this is basically related to the nature of the service of Elastic Cache. So Elastic Cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about a database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an Elastic Cache, that data can be captured or can be cached inside Elastic Cache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from Elastic Cache, and that is the exact use of Elastic Cache, right? So you use Elastic Cache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an elastic cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the request to page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. Alright, so I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Request to page option to access via AWS billing, again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would we do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you are using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS. So there is no chance of any leak in terms of security aspect. Second thing is, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So this is a simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you have entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed. True. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time, you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are 2 types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite. That is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? All right, so to rephrase this question, basically you have an application which has 2 kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the tasks should be completed in 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the backend, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, And as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that a database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. Alright. Our next question is, which component of AWS global infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible. And it is possible using AWS edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.